Hi, welcome to the Cisco SD-WAN course where we will cover the fundamentals of Cisco SD-WAN along with demos. First of all, let me introduce myself. I'm Vignesh Pandurangan and I have about 11 years of experience in network industry and specifically about Cisco SD-WAN. I have been working on this technology for about 5 years now. The prerequisites for this course will be good understanding on R&S, how IPsec based channels work, and a bit of idea about WAN networks. Apart from that, I don't see any other major things which you may need to know before jumping into this course. At the end of this course, you should be definitely in a position to build your own Cisco SD-WAN setup with all the core functionalities. I have also shared the link for the lab topology diagram in the description box. This is the exact lab topology which we will be using in this video. If possible, please download and print this diagram so you can reference them while going through this course. Finally, if you are looking to gain knowledge for designing, implementing, or providing operational support to Cisco SD-WAN enabled network, you are in the right place. Let's get started. What are current challenges in WAN? Why do we need SD-WAN? And what are some of the differentiators of Cisco SD-WAN from other vendors? In current WAN network, there are some challenges which we face. Some of them are insufficient bandwidth. There might be cases where you may have dual MPLS or internet connectivities to a site, but we cannot natively do active-active load sharing to utilize both the circuits. Limited application awareness. We will have very less visibility into the applications that are being used in the WAN network. Applications downtime. Think of a scenario when you have a site with dual links and all the traffic is primarily sent via the first link. When there is heavy packet drops or loss in the first link, our critical applications may still try to use this first link, by which the application may suffer. Fragmented security. To enable end-to-end security in traditional WAN network, it is a tough job and a complete manual effort which will be huge. No cloud apps readiness. Integrating with the cloud-based SaaS or IaaS providers is not natively built in. Some examples of SaaS will be O365, SharePoint, and examples of IaaS will be logical space which we will get in AWS, Azure, or GCP. Some other challenges are limited scale, high cost, and complex operations and management. Software defined WAN is nothing but a way in which we will be able to centrally provision the network and also to manage, monitor, report, or even troubleshoot the network. Lots of the manual efforts which we will make in managing the traditional WAN networks are automated in SD-WAN solutions. Some of the advantages we may get with the software defined WAN solutions are the operational cost will be low, application performance and network quality of experience will be increased. You will understand this when we look at policies, application aware routing in the future sections of this video. Also, security and data privacy can be provided natively as a part of the solution, which will save huge effort in terms of configuring and managing the same. Some of the differentiators of Cisco SD-WAN solution Viptala are cloud or on-prem delivered SDN architecture. Both options are available for the customers to use. The controls can be brought up in the cloud where we will have a variety of options. Also, if in case the requirement is to build the same on-prem for any reason, the same is possible as well. Application quality of experience will be high for any on-prem or cloud hosted applications, as we discussed in the last slide. Say for example, we have options to track the performance of O365 application via all our available paths and take decision to send the traffic via the best performing one. There is many more options which will enhance the application experience in Cisco SD-WAN. Comprehensive security. Security is the heart of this solution. Anything and everything in Cisco SD-WAN solution is secured. For example, what are the hardware devices which are allowed to get onboarded in the network is restricted. Also, the control and data plane traffic is completely secured as well. Flexible operations. The management of the network is very simple since most of the stuffs are automated and also controlled from a centralized controller. Let us discuss about the different types of components which are available in Cisco SD-WAN solution. Also, we will discuss on each of their roles in the network. The first one is vBond, which will be the orchestrator plane. vManage and vAnalytics are the management plane components. vSmart is the control plane component, and data plane will be the WAN edge routers. Let's start by looking at the vBond in detail. You can think about vBond as the gatekeeper. Every device in the Cisco SD-WAN solution, including the vManage, vSmart, and WAN routers, must first authenticate themselves successfully with the vBond, and then only they will be able to speak with any other components in the network. Distributes list of vSmarts vManage to all WAN edge routers. When a router in any site comes up, it first reaches out to the vBond, and vBond is the one who will inform edge router about the other controllers in the network, say vManage or vSmart. Facilitates NAT traversal. The vBond does act as a stun server, session traversal utilities for NAT, meaning in case if you have a branch where the ISP have provided you a modem and the SD-WAN router is connected behind the modem, in this case the SD-WAN router will mostly get a private IP address assigned by the modem, and when the traffic exits the modem, it will NAT it to a public IP. In this case, the vBond will be able to identify both private and public IP address natively. Requires public IP address could sit behind one-to-one NAT. When we bring up a vBond, wherever it may be, in a cloud or on-prem, if the vBond is sitting behind a NAT, it should be a one-to-one NAT. Also, we have to make sure that every device in the network should be able to reach the vBond IP address at any case. Highly resilient. We can have multiple vBonds in a network for redundancy. Mostly it will be one in a DC and one in a DR. Next one is the vManage, single pane of glass for day 0, day 1 and day 2 operations. vManage is basically your one-step graphical user interface for everything. New device bring up, changes to an existing network, monitoring the performance of the network, reporting, etc. Multi-tenant with web scale. A vManage can be either single tenant or multi-tenant. Both options are available. Centralized provisioning, meaning any new device bring up is done with the support of vManage. Policies and templates. Network-wide policies or a device-specific policy, everything will be created from vManage only. Followed by troubleshooting and monitoring, which can also be done from the vManage. Software upgrades, GUI with RBAC. Role-based access control is available for the vManage, meaning we can customize which user gets access to which sections of the vManage. Programmatic interfaces, REST, netconf. The next big thing with the vManage is APIs. We can query the vManage with API call so that it returns data. This data can be further used to prepare our own custom dashboards, or also we can do configuration changes to the vManage with this APIs as well. Highly resilient. We can have multiple vManage devices built in a cluster for redundancy purposes. One another component in the Cisco SD-WAN solution is vAnalytics. The first thing to note about vAnalytics is that it is only available as a SaaS, just like your Office 365. The vAnalytics in general is the component which is going to provide you rich analytics about your network, starting from link utilization up to granular application level reports. On a high level, the vManage actually collects the data from all the SD-WAN routers and then share the raw data with vAnalytics. vAnalytics will process this data to provide us great reports. Next, let's look at the control plane component of Cisco SD-WAN solution, which is the vSmart. Facilitates fabric discovery. vSmart is the device which shares control plane informations between the routers in all the site. The SD-WAN routers doesn't share routing informations directly. vSmart is very similar to a BGP route reflector, but with advanced functionalities. Dissimulates control plane information between WAN edges, meaning shares the routing information between the SD-WAN routers in different sites as I informed. Distributes data plane and app hour routing policies to the WAN edge routers. vSmart is responsible for key exchange as well. As you are aware, the primary functionality of an SD-WAN is security. Data traffic is completely encrypted between the sites. For this encryption to happen, we need key exchange, right? How do we do this in our regular IP signal? We create phase 1 to securely exchange this key, isn't it? But here, since we have the vSmart already available, and also Vantage and vSmart have a secure control plane connection already built between them, the key exchange between the sites will happen through this tunnel with the help of vSmart. vSmart also helps in pushing the application-aware routing policies to the required sites. This we will look in detail in later sections. Implements control plane policies such as service chaining, multi-topology, and multi-hop. In Cisco SD-WAN, we do service chaining and a lot of other things. In all those cases, vSmart will be the one implementing those changes in the network. Dramatically reduces control plane complexity. Since you understand all the SD-WAN router doesn't exchange routing or other informations directly between them, rather they always communicate via the vSmart, right? There is no need for direct peerings between the sites. Obviously, this reduces major complication in the control plane. Highly resilient. Yes, we can have multiple vSmarts for redundancy purposes. Let me stop here. So far we have learnt about vBond, vManage, vSmart and vAnalytics. These are the controllers. Maybe they are sitting in the customer data center itself or in Cisco's data center or in AWS, Azure Cloud or anywhere, right? These components is going to take place only in the control plane of the solution, not in the data plane at all. Remember this, okay? The final device which we are going to discuss is about the SD-WAN edge routers. Throughout this series, you will hear me calling these in common as the WAN edge routers. Hope you know Viptela was a separate organization before Cisco have acquired it. After Cisco acquiring Viptela, there have been huge enhancements to the solution. One of it is making all the existing Cisco routers to support or join the Viptela SD-WAN solution. Viptela had their own hardware before, which we will term as V-edges, and Cisco routers which can support SD-WAN is called C-edges. So if you hear me saying V-edge, it means Viptela hardware, and if I say C-edge, it is a Cisco hardware. Provides secure data plane with remote managed routers. The primary role of this WAN edge routers is in the data plane. They forward the data packets securely between the sites. The routing and IPsec key details are shared by the controllers to these WAN edge routers, as we already discussed in the previous slides. Establishes secure control plane with vSmart controllers, OMP. As discussed earlier, there will be secure control plane connections built from the WAN edge routers to the vSmart. Via this tunnel, the routing, policies and other IPsec details are also shared securely. The protocol which is going to support to exchange all these details between the vSmart and WAN edge routers is the OMP, Overlay Management Protocol. We will look at this OMP in an upcoming section. Implements data plane and application aware routing policies. When there is a need that you want to do application based routing and you create a policy, obviously you will create the policy in the vManage via GUI, but it will be pushed all the way up to the WAN edge routers. So they will send the data traffic according to the policy. Now, where this WAN edge router will connect to on the LAN side, obviously to any core switch in the site, right? So it does support traditional routing protocols as well. Not only in the LAN side, we can definitely configure these protocols on the WAN side as well. Support zero touch deployment. It is nothing but, say for instance, you buy a new router and send it directly to your branch office. You can call your local admin there to connect the router to an internet link with DHCP DNS enabled. You are good to go. The router have the capability to automatically find a way to reach the vBond, vManage and vSmart devices and join the SD-WAN overlay. This is called as ZTP, Zero Touch Provisioning. Physical or virtual form factor. We have hardware routers and also virtual routers. The virtual routers are mostly brought up in the cloud data centers like AWS, Azure, GCP, etc. Note, in our course, we will be using only these virtual routers in our lab to demonstrate. We will be discussing this in detail in the later stages when we get into the demo sections. Okay, just a quick recap. The components that make up the Cisco SD-WAN solution are vBond, vSmart, vManage and WAN edge routers. It can be either V-edge or C-edge. vAnalytics is an optional component only available as a SaaS solution. Whether you deploy the controllers vManage, vSmart or vBond in an on-prem DC or anywhere in a cloud, they are only available as a virtual component. So basically you will bring up these as a virtual machines on top of an hypervisor. There is both support for ESXi and KVM hypervisors. As we discussed already, the WAN edge routers can be both physical and virtual. Also, note that there is as many as variety of Cisco hardwares out there which can support SD-WAN functionality. Say for instance, ISR 4Ks, 1Ks, ASRs, etc. Now let's look into the major and important terminologies which you need to get familiar with. Don't worry, even if you are not able to understand them clearly here, you will obviously get hold of them as the course progresses, since we will use this term repeatedly. The gray box you see here represents an WAN edge router. On a high level, we can say that the WAN edge router is segregated into three separate VPNs. In Cisco SD-WAN, VPN is nothing but VRFs in your traditional routers. So we have a transport VPN, the red one in my slide, and if you see, it also have an ID which is VPN 0. The transport VPN is where we terminate all our WAN links, whether it is MPLS or internet, they all will get terminated on this VPN if they are going to act as an SD-WAN transport. Also note, VPN 0 number is dedicated to transport VPN. So if you hear me saying transport VPN or VPN 0, I'm talking about the VPN where the WAN links are getting terminated. Okay. Also note that we always have only one transport VPN. The next is the service VPN, green one in my slide. This is where the LAN links connect. Say for example, your core switch in the site may terminate on this VPN. We can have multiple service VPNs. Think in your office, if you have user machines and voice traffic, we can create one service VPN for the user data and one more service VPN for the voice traffic. Then we will just assign them each with a different VPN number. The service VPN numbering can range between 1 to 511. I want to highlight one more thing here. Since the range of service VPN numbers can be between 1 to 511, it doesn't mean that we can create 511 service VPNs in a router. The routers, depending on the hardware and licenses, can support only a limited number of service VPNs. But you are free to assign them with any numbers between 1 to 511. Out of band management VPN or the OOB VPN, the yellow box in our diagram, it is in short nothing but an out of band connectivity to the box itself. This VPN really doesn't have any other functionalities. The number for this VPN is 512. Let's start with the most common terminologies of Cisco SD-WAN which you need to grip to follow me throughout this course easily. First one is the transport side. This we have discussed in the previous slide. This is the place where the WAN links connect. Also, we will call these connectivities as the underlay connectivity or underlay network, because only on top of this path, the SD-WAN routers will form the overlay tunneled network. This transport VPN is always the VPN 0, and this is where the traffic gets encrypted and tunneled to the other sites. Also, there is options where we can say not to tunnel some specific traffic, rather send them natively on the WAN link. This is called as DIA, Direct Internet Access in Cisco SD-WAN terms. We have separate section talking about DIA as well, where we can definitely check this out in our lab. Service VPN. This is the one connecting to the LAN side. The VPN numbering can range between 1 to 511 and 512 is reserved for OOB, just like the way in which VPN 0 is reserved for transport, right? Here in this service VPN, we will see the actual original traffic from or to the LAN. This is one important term that I want you to understand, TLOC. You can think of this as an identity card given to an WAN interface. Go back to your school days for a moment and think what details your school identity card will have. Your name, which standard, and maybe a section, and also the school name, right? All these details makes up your identity card, and in turn that card gives you a unique identity, right? Same way, TLOC is a collection of system IP, color, and private and public IP addresses. With this TLOG details, we will be able to uniquely identify an WAN interface in the complete network. By the way, you might ask me what is a system IP or color in the first place. Just hold on for a minute, we are going to talk about them separately. The V route. It is nothing but the routes available in the service side VPN. As we discussed already, VPNs is nothing but VRFs, right? So every VPN will maintain their own separate routing table. This V route is also called as service routes. You will definitely hear me using the term service routes more often. OMP. This is an important one in Cisco SD-WAN. OMP is the routing protocol which runs only between the vEdge routers and vSmart devices. Using this OMP protocol only, the vSmart exchanges the routing updates between the sites. Not only that, policy details, IPsec keys, etc. are also shared using this protocol only. Next is the site ID. It is just an identification given per site. If there is two routers in a site, both will be assigned with the same site ID, by which the Cisco SD-WAN can understand that both routers belong to the same site and there will be no IPsec tunnels formed between them. Not only that, site ID is used when writing policies as well. It is one of the mandatory configurations. System IP is nothing but an router ID for the Cisco SD-WAN component. Every device starting from vManage, vSmart, vBond and the Vantage routers, everyone have a unique system IP assigned to them. If you are familiar with the router ID concept in OSPF, BGP or any other routing protocols, this is the equivalent here in Cisco SD-WAN. It is a 32-bit dotted decimal value looking like an IP address. We have talked about OMP protocol in the last slides, right? Say for example, when an OMP neighborship is formed between a Vantage router and a vSmart, it is formed between these system IP addresses. Organization name. Organization name is something which is assigned to every component in the Cisco SD-WAN network, and it should be exactly the same throughout the Cisco SD-WAN overlay. It is definitely case sensitive. This value will come into picture when SD-WAN components authenticate between them for control connection formation. There is also one more thing which I haven't mentioned in the slide, that is the SP organization name, which is the service provider organization name. This term will come into picture when we are enabling a complete end-to-end multi-tenant Cisco SD-WAN setup. What is a zero trust architecture in Cisco SD-WAN? Basically, no one is trusted in Cisco SD-WAN until they authenticate successfully with a certificate, serial number or other parameters. Now, when we bring up the head-end controllers, they authenticate between them using a signed certificate. And how do they get the signed certificate in first place? It is from a certificate authority. Also, they use serial numbers to authenticate between the controllers in certain scenarios, but predominantly the certificate is the mechanism using which the authentication happens. In terms of the root certificate, it is already available in the operating system itself. And if in case you are using an enterprise CA, you should upload the enterprise based root certificate to all the controllers manually. The concept of Cisco SD-WAN is that any Vantage routers coming up in the network should be allowed specifically by the administrator to join the overlay. Only then they will form control plane connections with the controllers, and then followed by that data traffic forwarding will happen. If a router serial number is not allowed, they will not be able to join the network at all. This serial number file is generated in the PNP portal and uploaded onto the vManage, and then vManage will distribute this serial file to all other controllers in the network. The serial numbers can be kept in different state. First is valid. When it is listed as valid, the router will be allowed to form control connections with the controllers, followed by they will start participating in the data forwarding. Invalid state means that the router is not allowed to join the SD-WAN network at all. The last state is staging. When a serial number is marked with staging option, then the router will be allowed to form only control connections, but it will not be able to form any data plane tunnels with the other routers. When the Vantage router wants to come up in a network, the first device it will try to form a control connection is with the vBond. While trying to form control connections, Vantage router will submit its signed certificate and vBond will authenticate the same. Also, the authentication process will happen in other direction as well. where VBond will share its signed certificate to the WAN edge router, which will be authenticated by the WAN edge router. Along with this signed certificate authentication, the controllers will check the serial file list whether the WAN edge router is allowed or not. The WAN edge router will get its root CA from the operating system, whereas the signed certificate is built into the tamper-proof hardware chip when shipped from the Cisco itself. If in case this is a virtual router, then there will be a slight difference where the virtual router should reach out to the vManage in order to get a signed certificate. Also, if you are using your own enterprise-based certificate authority, then you should manually upload the enterprise root certificate to the WAN edge routers. Let's look into how the overlay routing works in Cisco SD-WAN and also about the protocol which supports in route and other attribute exchange process. Overlay management protocol is the control plane, that is the routing protocol of the Cisco SD-WAN overlay. It does act as a route reflector to share routing informations between different SD-WAN sites, and also along with routing information, it does carry additional details such as VPN, service chaining, etc. Using the updates from the OMP, an SD-WAN edge router will be able to decide upon how and whom to send a particular packet to. It does share the security association parameters for establishing secure IPsec tunnel between the different SD-WAN branches. Overlay routing, application-aware routing, and centralized data policy details, etc. are also shared via OMP updates from vSmart. OMP peering is established between the system IP addresses of each SD-WAN edge routers and vSmarts. From every SD-WAN edge router, there will be only one OMP peering formed to a vSmart irrespective of the number of transports available. So in case there is 3 transports on the edge router and there is 2 vSmarts in the overlay, you should see 2 OMP peerings from the SD-WAN edge router to the vSmarts. Okay, let's look at this example on the screen. There is 2 vSmarts and 1 SD-WAN edge router. Also, there is 2 transports available, one MPLS and one internet. vSmart and WAN edge router both are connected to both the transport. In this scenario, between the vSmarts themselves, they do establish the OMP peering, so they can be completely synchronized between them. DTLS or TLS based control tunnel will be established from the SD-WAN edge router to the vSmart one via both MPLS and internet circuits. After that, OMP peering session will be brought up automatically between the WAN edge and the vSmart one. Same process will be followed between the SD-WAN edge router and the vSmart 2 as well. Control tunnels will be formed via MPLS and internet transports from the SD-WAN edge router to the vSmart 2, and OMP peering is established between them as well. Via these OMP peerings, all details like routes, service, and policy, etc. will be shared. In general, there is 3 types of routes which the OMP carries. First one is TLOC routes. TLOC routes does carry the details about WAN interfaces. To be precise, the transport interfaces. Whether it is a MPLS or internet interface, they have certain attributes like WAN IP, port number on which they listen, and also there will be IPsec parameters for them as well. To convey this in short, all the data about the WAN interfaces are shared via this TLOC route updates of the OMP. The most prominent attributes carried in a TLOC route update are site ID, encap detail. These are the IPsec parameters for the TLOC. Public IP, public port, private IP and private port. This is the port details on which the TLOC will listen or accept the connections on. BFD status, tag, preference, wait, etc. Preference is nothing but a regular preference to the TLOC. It is a value which will be shared to the other sites and based on which the other sites will take decision about which TLOC to prefer. Wait is a local attribute which helps the local router in deciding which TLOC is a preferred path. The next type of route is the OMP route, which is otherwise termed in general as VPN route, service route, and also sometimes as LAN route. They are basically the LAN prefixes on the SD-WAN edge router's service VPN. These routes will be advertised from all service VPNs of every SD-WAN edge router to the vSmarts. The most prominent attributes carried in a service route update are TLOC, which is the WAN interface IP address details of the site where the specific LAN route is available. Based on this detail, this service route will need to do a recursive lookup into the TLOC route table as we discussed previously. And then there will be site ID, label. Label helps in identifying which VPN the route belongs to. And then VPN ID, tag, preference, originator system IP, origin protocol. This is the LAN protocol from where the route is redistributed. And finally, the origin metric. This is the metric which is carried from the LAN protocol. The final type of route is a network service route. To put it in simple way, say for example, if you have a firewall IPS or IDS in your data center and you want all your branch locations to use this service in the data center for specific traffic, then the first step we have to do in Cisco SD-WAN is that we have to add this firewall IPS or IDS to the data center SD-WAN router as a service using the service route option in Cisco SD-WAN. When you create a service route, this service route gets populated automatically throughout the overlay. Then after this, we need to create a data policy and direct traffic towards that specific service so that all the required traffic matching in the data policy will flow via that service as we need it to be. In this case, the service route should be advertised into the overlay, isn't it? This is done by the OMP protocol in the form of network service route. We will explore service chaining in detail in our channel, but for now I hope you are able to get a basic idea about this type of route. The most prominent attributes carried in a network service route are VPN ID, service ID, label, originator system IP, and TLOC. Let's quickly discuss about timers and values in OMP. Number of advertised routes in vSmart and Manage. So by default, only 4 next stops will be advertised by a vSmart or a Vantage about a specific subnet. We can change that anywhere from 1 to 16. Number of installed OMP paths in Vantages. Even though you receive any number of OMP next stop paths, we can decide how many paths will go into the routing table. Default 4 and it can be between 1 to 16 as well. OMP hold timer. This determines how long you should wait before declaring an OMP peering to be down. By default, it is 60 seconds and it can be configured between 0 to 65535. And also as a thumb rule, we should make sure that it is 2 times higher than the hello tolerance interval set on a WAN interface. OMP update advertisement interval. This is the speed in which OMP sends update packets. Default 1 second and it can be between 0 to 65535. End of rib. When an OMP session goes down and comes back up, after 5 minutes an end of rib marker will be set and sent. Once it receives an end of rib marker, any routes that were not refreshed after the OMP session came back right, they all will be considered as stale and they will be deleted from the routing table. By default, it's 5 minutes and it's configurable as well. Now let's discuss about control and data plane in Cisco SD-WAN and also how segmentation is achieved between different VPNs. We will also see how control and data plane are secured in Cisco SD-WAN. On a high level, Cisco SD-WAN does form DTLS or TLS based secure tunnels between the controllers and as well as from the WAN edge router to the controllers. Whereas between the WAN edge routers, they form IPsec tunnels. But the biggest difference about the data plane IPsec tunnels in Cisco SD-WAN is that we don't have a phase 1 at all. The key exchange will happen via the secured DTLS tunnel which we already have with the vSmart device. In terms of the control plane tunnel, which is the DTLS connection, encryption is handled with AES 256 and integrity by SHA-1 or 2. Also, the devices will exchange digital certificates as we discussed in previous sections, which is a signed certificate between them for the authentication purposes. Now, what's next after DTLS or TLS based control plane tunnel is successfully established? Every communication, including the OMP route or policy exchange or any netcom sessions, whatever it is, right, will be communicated via this secure DTLS or TLS tunnels. In turn, this makes everything secured in Cisco SD-WAN. If you remember, I have told you there is no phase 1 at all for data plane IPsec tunnels in Cisco SD-WAN routers. Then you might think how the key exchange between SD-WAN routers will be secured. Obviously, it will be. The WAN edge router doesn't speak directly for anything related to control connectivity, right? So all the control plane communications and key exchanges will happen via the vSmart. And obviously, we already have a secured DTLS or TLS based tunnel between the WAN edge router and vSmart. So everything is already secured in control plane. So we don't need to maintain a separate phase 1 tunnel between the routers like we do in our traditional network. Let's quickly discuss about the control plane timers. First, hello interval. It is the keep alive in which hello packets are sent in a DTLS tunnel, right? By default, it is per second and it can be between 100 milliseconds to 60,000 or 6 lakhs milliseconds, which is 10 minutes, right? Hello tolerance is nothing but how long should I wait before declaring a tunnel down. By default, it is 12 seconds and it can range between 12 through 6,000 seconds. Let's quickly look at the high level of data plane security in Cisco SD-WAN. In our topology, we do have 2 WAN edge routers and 2 transports and 1 vSmart, which is going to help in the control plane. First, a DTLS or TLS based control plane tunnel will be formed from each of the WAN edge router towards the vSmart. And then within this tunnel, a OMP session will also be formed. Followed by that, OMP updates will be exchanged via these OMP peerings. Basically, it will carry the routing information, IPsec key parameters and other data. Once this data is exchanged between the sites, the WAN edge routers will go ahead and establish a direct data plane IPsec tunnel, which is a BFD tunnel. Let's quickly look at how data plane key exchange happens in Cisco SD-WAN. If you look at the diagram, here we do have 2 T-locks. And also on the other end, we do have 2 T-locks, which is 2 transport interfaces, right? For each of the T-locks, each router will generate a separate encryption key. So if you see on the left, there is encryption key 1 and 2, which is generated by this router for both of its transport interfaces. The orange key on the right, which is encryption key 3 and key 4, are generated by that router for his own T-locks. So how these keys are exchanged between the routers? Obviously, as we discussed already, it's via the vSmart. So now the edge routers would have received the other side's encryption key as well. Now when the left side router wants to initiate a communication to the right side router, he knows about the encryption key of that router as well. So next step, they will go ahead and establish a BFD tunnel. You see here, from this router, he uses encryption key 3 when he is sending packets out of this transport towards the other side, whereas in the other direction he is using key 1, right? Same way, if we see the tunnel which is on the bottom, this router is using encryption key 2 when he is sending traffic to the other side via this tunnel, and from this router's perspective he is using encryption key 4 when he is sending traffic from this router to the other router via this specific transport. This is how the key exchange happens in Cisco SD-WAN. Let's quickly look at the data plane timers as well. First, hello interval. It is basically the hello packets sent on the BFD tunnel which we have. By default, it is 1 second and it can be between 100 to 6 lakh milliseconds. And then the multiplier. So multiplier is not in seconds, right? Say for example, by default, the hello interval is 1 second and the multiplier, if you see on the screen, is 7 for hardware edge routers, right? That means it will declare the tunnel to be down after 7 seconds. And if you change this hello interval to be 2 and keep the multiplier as 7, that means 2 into 7, which gives 14. He will declare the tunnel to be down after the 14th second. Okay, we have already discussed that we can create multiple service VPNs in a Cisco SD-WAN router, right? So if you see this diagram, we do have 2 service VPNs, VPN 1 and 2 on this router, and as well as on this router, we do have VPN 1 and 2. Between these 2 routers, we will obviously have only one IPsec tunnel. then how do the other router will know which VPN the traffic belongs to? It is basically achieved with a label in Cisco SD-WAN. So based on the label, the other end router will be decrypting the packet and assigning the traffic directly into the specific VPN. Say for example, if a VPN 1 is assigned VPN label 101 in the overlay, when site 1 sends the traffic, it will tag label 101 and encrypt the data and send it over the transport. When the other site receives that, it's going to decrypt the packet and see the VPN label, and it will decide that the traffic belongs to VPN 1. This is how we will achieve end-to-end segmentation in Cisco SD-WAN. Let's now look at what is a certificate authority, followed by the different ways in which Cisco SD-WAN controllers can get their signed certificate, which they can use for authentication purposes. Let's see how a certificate authority works in general. As we know, lots of services use a certificate-based authentication like our Cisco SD-WAN solution. The left side box represents an applicant and the right one is a certificate authority. In our case, the applicant will be vManage, vBond or vSmart controllers. An applicant will generate a key pair consisting of a private key and a public key along with a certificate signing request, which is a CSR. A CSR is an encoded text file that includes the public key and other information that will be included in the certificate. Example, domain name, organization name, email address, etc. The applicant will have a private key as well, but it is not going to be shared outside at any instance. After generating the CSR, the applicant sends it to a CA who verifies that the information it contains is correct or not. If all informations are correct, it digitally signs the certificate with its private key and sends it back to the applicant. This is the certificate which will be used by the applicant in order to authenticate any clients who may reach to him. We already know that all our controller components are only virtual devices and they will get the root certificate in their OS itself. But to get a signed certificate, they must go to a certificate authority. There is multiple options available for Cisco SD-WAN in which it can get a signed certificate. First one is automated Symantec or DigiCert based signing, manual Symantec or a DigiCert model, automated Cisco PKI based CA, manual Cisco PKI model, and finally the customer owned enterprise certificate authority. Out of all these options, the current recommended option by Cisco is automated Cisco PKI certificate signing. Now we will look into details of the automated Cisco PKI certificate signing method and the enterprise CA model. In our lab today, we will use the fifth option, which is enterprise based CA model. Okay, let's start with the automated Cisco PKI server model. If you see my screen, we do have an admin and vManage, vSmart and vBond and a Cisco PKI server. Now let's see the process in which we can get a signed certificate for the vManage himself. The administrator first logs into the vManage and initiates a CSR for the vManage itself. Then the vManage will automatically submit the CSR to the Cisco PKI server hosted in internet. For this, the vManage will need internet access and also DNS resolution should be proper. Followed by that, the CSR is automatically approved and signed by the Cisco PKI server, and then vManage will be automatically retrieving that signed certificate from the Cisco PKI server. Basically, the vManage continuously tries to the Cisco PKI server whether or not the certificate is signed and ready. So once ready, he will just retrieve it. Now vManage, after receiving the signed certificate, he will install the signed certificate since it is for himself. Now let's back off for a second. Now let's say we need to get vSmart and vBond a signed certificate. Here in this case, vManage will act as a proxy. First, the admin will log into the vManage and initiate a CSR, but this time it will be for either vSmart or vBond. When the admin does that, right, vManage initiates a netconf for vSmart and vBond, and then he will request them for a CSR in the backend, and he will obviously get the CSR for them. Once the vManage gets the CSR, he will submit it to the Cisco PKI server. Cisco PKI server will approve that CSR and give a signed certificate. So vManage will retrieve that signed certificate. This time vManage will know that the certificate is not for himself, so he will render it to vSmart and vBond. This is how the Cisco PKI server automated method will work. Here we do have an enterprise CA server, vManage, vBond, vSmart, and an admin. Remember, the controllers will have a root certificate only for Cisco or Symantec or DigiCert based CAs. It will not have an enterprise based custom root certificate, right? So the first step here is we have to get the root certificate from this enterprise CA and then give it to the vManage, vBond, and vSmart. First, the administrator retrieves the root certificate from the enterprise CA server and he logs into the vManage and uploads the root certificate. And then vManage will help us in installing that root certificate into the vBond and vSmart as well. Once this process is done, then the administrator initiates a CSR. It can be either for the vManage himself or for the vBond or vSmart. And then he manually downloads the copy of CSR, takes it to the enterprise CA server, and then he will sign it manually in the enterprise CA server, retrieves the signed certificate, upload it back to the vManage. If the certificate is for vManage himself, vManage will install it, or if it is for the vBond and vSmart, it will render it to them. This is how the enterprise based CA model will work in Cisco SD-WAN. Let us have a quick look at the XCA application which will act as the enterprise root CA in our lab. We have detailed videos about how to install this XCA application and create a root certificate from the same. Check out the playlist link in the description box, and also I have given the particular videos in the cards as well. I have already installed the XCA application in my jump box, and also I have already created a root certificate. When I click on this root certificate, we will be able to see more details about this root certificate, and I do have created this root certificate with a 10-year of validity, plus these are the details which I have given when creating this root certificate. If you are looking for more details about how to install this XCA application and how to create a root certificate for our lab topology, I request you to visit the videos available in our Cisco SD-WAN video series. The link for the video series is given in the description box. For now, this is the root certificate which we are going to use in this lab topology. Also, I have exported this root certificate out into this jump box already. So when we are in the stage of creating our controllers and getting them signed, we will come back to this XCA with a CSR from them and then get them signed here and go back and install them there. Now let's see about the lab topology that we are going to use today, how I have built the lab in my server, what is the version that we will use in our demo. Just in case if you still haven't downloaded our lab topology diagram, it is available in the description box. Please do download and keep a separate hard copy or soft copy as you wish. But I feel if you have a hard copy, specifically a color printout, it will be great. We will use 20.6x code for vManage, vBond, vSmart, VH Cloud, and 17.6x for the Catalyst 8kV routers. We will use minimum specs for vManage, vBond, vSmart or Vantage routers, not the Cisco recommended specs, because obviously this is our lab environment. vManage, vBond, and vSmart will be brought up in ESXi directly as a VM, whereas I will bring up all the Vantage routers inside a GNS3 project. Okay, let's explore the lab topology now. First, to start off, we do have a data center with two Cat 8kV routers, and then on the bottom we do have two branch routers, branch 1 and branch 2. Each of the branches have only one SD-WAN routers, and we do have two transports, MPLS and internet. The internet that I have shown in the data center is just an internet which is going to help us in reaching the actual internet applications, right? Whereas this internet on the bottom is the one where all the SD-WAN routers will connect and then use that as an actual transport, where they will build tunnels over this internet. Think like I have this from ISP1 and this is from ISP2, right? And in the data center, we do have two different VPNs, which is VPN 10 and VPN 20. VPN 10 is a user data VPN, and I do have a server in data center which is residing in VPN 10. And VPN 20 is a voice VPN. I do have a CUCM server, maybe, right? Think this as a CUCM server or a phone or whatever it is. I do have an endpoint there, right, for our lab. If I come to the branch, Same thing, I do have VPN 10 and VPN 20 there as well. VPN 10, a user machine is sitting there in VPN 10, and we do have a voice phone sitting in VPN 20. Same thing goes for branch 2 as well. And if you see here, we do have a cloud hosted endpoint. When I say cloud hosted, it is not actually hosted in the cloud. It is in my lab. Logically, I'm going to call this as the cloud. I will extend the GNS3, this INET, which is available inside GNS3, to the outside world so that it can communicate with my VMs, which are these controller VMs available in the ESXi. I will walk you through this in great detail when we do the demos. I do have separate slides showing each sites separately, data center, branch 1 and branch 2. If you see data center, we do have two transport connectivity, and if you notice the interface number, it's colored in pink. If you see the legend, it says that whenever you see that color, that means it's VPN 0. That interface will be assigned under VPN 0. If you see some interface colored as green, it will be assigned under VPN 10. This is the reason which I have requested you to take a color printout, so that when you reference, you will be able to see these color codings as well. Even when you see the MPLS links or internet links or the internal links, I do have given them in separate colors so that you can understand that clearly. This is the topology diagram for branch 1, and followed by that we also have one for branch 2. We will discuss this in detail, and obviously we are going to use these diagrams when we build up our demos. We will now spin up the vManage, vBond and vSmart VMs in our ESXi server, and then followed by that we'll do some required settings. Plus, let us also just assign an IP address to these devices so we can easily access them via SSH or HTTPS as needed. Let's get started here. I am in the ESXi server now. If you see, I do already have installed vManage, vSmart and vBond VMs just to save time in our video. What I will do, I'll just quickly show you how to install a VM in this ESXi. First, click on Create Register VM and then select OVF or OVA file. Click Next and then give a name. So for now, let me give test. And then select the OVA file for the VM which you are trying to bring up. Say for example, let's do this one for now, right? Select, click Next, and then select the data store, click Next. Select the NIC cards and the VLANs as per your design, and power on automatically. I'm removing that, and click on Next and finish. Once you finish, the file will be uploaded and the VMs will be created. That is the stage the VMs are in, right? I haven't completed the basic configurations in the VM. I just spun them up in the ESXi. Let me click on this vManage, right click, edit settings. If you see here, when I created the vManage, I have edited the CPU and memory to be 16 and 16. This will not be the case in a production environment. Always refer to the Cisco recommended guide to set the correct CPU and memory as per your design. If you see, I do have added this hard disk additionally, which is around 100 GB. So I have done that by clicking add hard disk and click new standard hard disk. That will add an extra hard disk. And then I have assigned all the NICs under VM network. I do have a flat network in my lab topology. Let me cancel this. Same thing I have done for vSmart and vBond as well. I have just edited the CPU and memory for them. Apart from that, there is no other things which we have to do for vSmart and vBond. We don't need an extra hard disk and all. Only vManage needs an extra hard disk. That is for the statistics collection in the vManage. What we'll do now is we'll get into these boxes and then just assign them an IP address so that we can get into them via SSH, which will be easy for us rather than a console. So let's start with the vManage. Right click, console. Let's first log into the vManage. Just asks you to change the password. I'm changing the password. The first step it asks you is you have added an extra hard disk. So what should I do with that hard disk, right? And also in the latest version, it will ask you what I am, right? Whether I'm going to act both as compute and data, or I'm going to act only as a data or compute. If you are doing a standalone vManage, you should always select option 1. In case if you have a cluster, this option will vary, right? You may have one vManage doing only data and other vManage doing only compute, right? So let me click 1 and then yes. You see, it have detected the extra hard disk which we have created. So it's requesting us whether it's going to use that for the storage. Yes, okay to format. Now the vManage will reboot and come back up. So let's give it some time. We'll come back to the vManage. Meanwhile, let's get into the vSmart and then assign them the IP as planned. Default username password is admin. I'm changing the password. So let's use Ethernet 0 as planned. VPN 0 interface Ethernet 0 IP address 192.168.0.53/24. No shutdown. Right, let's do this. IP route 0000 50. This is our gateway as per our plan. Let's commit and quit. Let us quickly check this configuration. VPN 0. Yes. So if you see, I haven't done anything else apart from just assigning an IP address. We will come back and do further configurations in a later section. So let's quickly get here, and I do already have created these things. So let me double click on vSmart. Yes, we are able to SSH into the vSmart. Let's just quickly get in and check. Yes, we are in the vSmart now. Same way, let's go ahead and get into the vBond console. Admin, change the password, and then if you see here, show interface tab. So I'm going to use Gigi00, and let me get into VPN 0 interface gigabit 00 IP address 192.168.0.52 as per our plan and /24. No shutdown. One more thing to note here is the vBond doesn't have a separate OVA file. We will use the vEdge image to bring up a vBond. We'll spin up a vEdge image in the ESXi, and then we'll get into the vEdge router and we will enable the vBond process in the vEdge so that it starts acting as a vBond. Since by default this is a vEdge router, every interface will be enabled with tunnel. So what we have to do is we have to allow all service so that we can SSH into this box. Let me do this as well, and then let me add the static default route. .50, commit and quit. Okay, now let's me get back here. Let's check vBond. Yes, I'm able to get into the vBond. Admin. Yes. So we have the vSmart and vBond accessible from our jump box. So let's get back and see what's the status of our vManage now. We have rebooted him, right? Let's go back there. Yes, he's ready, I think. Let's check. Here you go. Yes, I'm going to use the same ETH0 here as we did in vSmart. VPN 0, interface ETH0, IP address 192.168.0.51/24, no shutdown. IP route 0.50 is the next step. Let's commit and quit. Let's get back here. Check vManage. Yes, we are able to get into the vManage as well. One more thing, let me show you this. If you see, these are the image files which I have used to bring up the VMs in the ESXi server. Viptela Edge, this is for the vBond, Viptela Smart, and Viptela vManage for the vManage itself. And we are running 26.1 version in the controllers. Now we have remote access to all our controllers. Only the controllers will come up directly in ESXi server as VM. The other components in the topology as described in the diagram will come up in GNS3 server. To save time, I have already created this lab topology in GNS3. Now let me just walk through this quickly so you can be in sync with me. Let me give you a quick walkthrough of our GNS3 topology. If you remember, I have told you that we'll bring up the controllers directly as a VM in the ESXi, whereas all the edge routers will be created in a GNS3 project. So if you see my screen, this is the GNS3 project which I have created. This is as per the lab topology diagram which I have shared to you. There is a DC router 1, DC router 2, and behind that there is a DC switch which is an XSOSV, and DC server, DC phone, and I don't have real internet, so I have simulated the internet with a router here, and also there is the internet cloud, MPLS cloud, which are again simulated with a router only. If you see here, I do have netem. This is for inducing latency in the link. I'd say the link from branch router 1 to the MPLS. If I want to increase the latency here, I will use this application to increase the latency loss and jitter, right? Followed by that, we have our branch router 1 and branch router 2 with their respective end hosts. If you see here, the iNet 1, it has some connectivity to the internet servers, and also I have extended and connectivity to the outside network. Since all the edges are residing inside the GNS3 as a project, it needs some way to reach to the controllers which is sitting as a VM in the ESXi itself, right? So there is an option in GNS3 in which we can extend the connectivity from the virtual routers inside the project to the external network. So that is what I have done, so that these routers will be able to reach to the controllers. And also I have completed configuring this MPLS and iNet, so we will not be doing configurations for these routers in this video. It is already configured, whereas the DC switch is also partially configured, meaning I have already configured internet connectivity for this router. So if I go to this DC switch now and ping the internet server IPs which I have created in this router, I will be able to ping them. Same way from internet one also, I should be able to ping those internet servers. And also I have already logged into this server phone, and also in the end host of branch 1 and branch 2, I have assigned them an IP address and set a default route as well. If you see our lab topology diagram, the phones will get a DHCP IP address from their respective routers. So what I have done is I have went into this interface and then configured it to get a DHCP IP as well. So all the end host respective configurations are completed, and the MPLS and the internet cloud configurations are completed, and also the internet server related configurations are completed. So we will focus majorly on the SD1 router configuration in this video, plus some LAN related configurations which I kept pending. We will do that together in this video as well. So far, we have created the vManage, vBond, and vSmart VMs in the ESXi, but we haven't configured them. In this section, we will prepare the basic configuration needed for our vManage, and also there is some initial settings needed to be done via the GUI, which we will do. Also, we will install the enterprise root certificate onto the vManage. I am in the vManage SSH terminal. I have already created a basic configuration template for this vManage. Let me open that. Yes, if you see here, this is the template which we are going to use. We will fill up this template so that we will be able to build the basic configuration required to bring up the vManage. So to start off, we do have the system level configurations, which covers host name, location, system IP, site ID, organization name, what's the time zone, and also who's the vBond. If you see, I have given the vBond as lab.vbond.com. And again, I have created a host entry for that lab.vbond.com FQDN, right? If in case you have a DNS server in your real production, you might use the DNS server to resolve this. And followed by that, we do have the VPN 0 configurations. If you remember, VPN 0 is the transport VPN. Under that, we have configured the DNS and also the host entry as I told you. Plus, this is the WAN interface of the vManage. And we'll configure an IP address and we'll configure that as a tunnel interface. So let's start preparing this configuration. Host name is going to be vManage. Location, I'm going to use Chennai. And this lat long I have already pulled out from the internet and pasted. System IP is going to be 1111 and site ID is going to be 1. System IP, site ID, these things I have planned for my lab network. If in case you are doing this in your production, it depends on the scale of deployment. We have to plan that properly. And the organization name for our lab will be let me use that. Now clock time zone will be Asia Kolkata vBond lab. Okay. And DNS server I'm going to use 4222. Secondary is going to be 8888. And the vBond IP in our network should be 052 as per our plan. And ETH0 is the interface. And if you remember, the IP which we have configured for the vManage is 192.168.051/24. Tunnel interface, I'm going to allow service all. Will not configure anything else there. Since this is my lab and to keep it simple, I'm allowing all service. And in case if you're doing this in production, you may allow only specific services which are required. In most of the cases, controllers will be sitting in a data center and we'll definitely have a firewall before them, right? So the security should be taken care of. The next stop default route should be 192.168.050. That's it. This is the basic configuration. Let me copy this. Get into the vManage config t, paste it. Yes, save the configuration. We are done with the basic configuration for vManage via CLI. We have to get into the vManage via GUI and also do some basic configurations there. Let's get into the vManage GUI now. Here I am in the vManage GUI. If you see, it's HTTPS 192.168.0.51:8443. That's how you access the GUI of the vManage. We'll use the same credentials. Let me do one thing quickly. Yes, let's log in now. Here you go. We are in the dashboard of the vManage. We'll come back to this later. Let's get into the administration and the settings page. Here in the settings page, we must do some configurations. Yes, we'll get into the organization name, and this is our organization name. Save vbond lab.vbond.com. Save. Alarms notification, nothing. Hardware managed certificate, we are going to leave it to be default on box. Controller certificate authorization, we are going to change that to be enterprise root certificate. Yes, proceed. Here I have to select a file, and then if you remember, I have created our root certificate, right? I have to select that root certificate. Yes, the vManage have taken the root certificate. Let me also set the CSR properties. This is the properties which we have used while creating the root certificate, and it will be city San Jose, state CA, and then organization will be Viptela LLC, country code US, email 2020 at it's 2020 at gmail.com, and the domain name is proxy.viptela.com, and the validity I'm going to select it to be 3 years. Okay, let's go ahead and click import and save. Yes, it's saved successfully. Let's go back. Manage cloud certificate, I'm going to leave it to be automatic. web certificate. We are not going to do that things. Let's quickly check the banner. We'll enable a banner. I'm just giving a random value here. If you are doing this in a production, you must take care and put that as per your office standards. Let's quickly go down statistics settings. We'll come back to these things when needed. Here it is, the tenancy mode. We are going to use single tenant, so we will not touch that. And then smart account credentials. In case if you are using the Cisco based automatic certificate authority, we should have given the smart account credentials, but since we are using enterprise CA, we can skip that for now. And apart from that, I don't think we need any other basic configurations. Yes, we are good now with the vManage. We have configured the vManage via CLI and as well as via the GUI. In this section, we will generate a CSR from the vManage GUI and submit it to the enterprise CA server to get a signed certificate. Once the signed certificate for the vManage is available, we will upload it back to the vManage. Okay, let's go. Let's get into the vManage configuration devices page. If you see under controllers, we do only have the vManage and it is in sync and certificate status is not installed, right? If I go to configuration certificates under controllers, we still have the vManage, but we don't have an expiry date or we don't have a certificate installed here as well. Let's get a CSR generated now. Click here and then click generate CSR. Download the CSR. vManage CSR is downloaded. Let's close this. Close. Let me open up the XEA and here click import. Select the CSR from vManage. OK. Right click. Sign him. And these options are good. And this should be this. Use this certificate. Restore all default. Extensions. Type end entity critical. This. And I'm going to use it for 3 years. Key usage. Digital. Key encipherment, Netscape, all these 3 CAs. Nothing in advance, nothing in comments. Let's click OK. Yes, we have generated the certificate. If I go to certificates, under the root certificate, we will see the vManage certificate. Let's export that. I'm going to export it to the, yes, I'm going to export it to here. Let's save it here. It's going to be in PEM format. OK. Yes, we have exported the certificate. Let's come back to the vManage and click install certificate. Let's select a file and then choose all files. Yes, here it is, the vManage certificate. Now when I install, the vManage knows that the certificate is for himself, so that he will install the certificate to himself. Let this complete. Yes, it's a success. If I go back here, under configuration, certificates, controllers, you see here we do have the certificate installed successfully. And also let me get into the vManage CLI and do a show control local properties. If I scroll up a bit, hold on. Here you go. The certificate is installed and the validity is up to May 2025. So we are good with the vManage. vManage is configured and it is certified. Now we will prepare the basic configuration needed for our vBond device, and followed by that we will see how we can request vManage to help us in uploading the enterprise root certificate to the vBond, get the CSR generated from the vBond and sign and upload it back to the vBond. Everything can be done from the vManage GUI itself. Let's see how this goes. We do have SSH access to the vBond already, and also I have a template for the vBond basic configuration. Let us fill the template. This is very similar to what I have done for vManage. The host name is vBond. Location, let's keep it the same one. Let it be that. System IP 1112. We have used 111 for vManage. We are going to use 1112 for vBond. Site ID 1, they are going to be in the same site. And lab, this is our org name. Let's keep the time zone to be Asia Kolkata. This is the key factor. If you see, there is an extra keyword here which states local, right? This will indicate the VH that he should act as a vBond. He is not going to act as a VH, right? This is a critical keyword. And then under VPN 0, we have to give DNS. For vBond, we really don't need DNS until or unless you need to ping a FQDN from vBond. We are going to remove that and we'll move forward with vBond IP, which is 52. We'll tell the vBond about the vBond himself, right? And interface is gigi00. IP address of the vBond is 52 as per our plan, 24. And when you are creating a vBond, we can create it with the tunnel interface, or we can also remove the tunnel interface altogether. So for simplicity, I'm going to remove the tunnel interface, and the next stop will be 192.168.0.50. This is it. Let me copy this, get back to the vBond, paste it, commit and quit. Show interface tab, my bad. Here you see the configurations have been taken successfully. Yes, that's good. vBond doesn't have a GUI. We don't need to do any other configurations. We are ready to certify the vBond now. Let's get into the vManage, and we'll go into configuration, devices, and under controllers, add controller vBond. IP address of the vBond 0.52. What the vManage will do is vManage will connect to the vBond, and then he will help vBond to get a signed certificate. I'm going to remove this option. We will do this manually. Let's click add. Yes, the device is added, but certificate is not yet installed. Let's go to configuration, certificates. Now under controllers, yes, from here I'm going to ask the vManage, hey, get the CSR from the vBond. So now he got the CSR from vBond. He would have queried the vBond in the backend and got this CSR from him. Now let's download this. Why vManage is acting as a proxy here? Because vBond and vSmart doesn't have a GUI interface, right? It's easy to do things via GUI. So vBond is acting as a proxy and helping us here. Here is the CSR, which is generated, but the name seems to be undefined. I'm going to just change it to be vBond, so that in case if we want to reference it later, we will be able to identify, right? So I have changed it. Let me open my XCA. Yes, under here, let me import the vBond CSR, successfully imported. Right click, sign him. Use this certificate extensions. It's an end entity, critical. It's gonna be for 3 years. Apply. Key usage, digital signature, key encipherment. Let's keep all 3 CAs. Nothing in advance, nothing in comment. Let's click OK. Yes, successfully created. Let's go here. You see there is a vBond certificate available now. Let's export. Yes, I'm going to export it there. Let's click OK. You see, there is a vBond certificate now. We have to get back to the vmanage. Vmanage is the one who is going to help throughout this process, right? Install certificate, select a file. This time let me choose the vBond certificate. vmanage will know that this is for the vBond, so he will install it to the vBond. It's a success. Let's get into the vBond. If I do a show control local properties, you see a certificate is installed in the vBond. Mainly, if you're doing anything in vBond, you should always use show orchestrator. That is the correct accurate command for vBond. Say example, if you're doing show control connections or show control local properties in vmanage and vsmart, the equivalent command in vBond will be show orchestrator local properties and show orchestrator connections. So let's do this as well. Certificate is installed and this is the certificate validity. Now both vmanage and vBond have their respective certificates ready. So what do we expect? We expect them to form DTLS tunnels between them. Let's just quickly validate that. In vBond, as I told you, we should do show orchestrator connections. Yes, if you see, we do have multiple connections to the vmanage. This is basically from every core of the vmanage will initiate a control connection. That's why there is multiple connections. Show control local, no, my bad. Show control connections. Yes, you see, we do have control connections to the vBond. In this section, we will prepare the configuration needed for our vSmart device, and followed by that, we will see how we can request vmanage to help us in uploading the enterprise root certificate to the vSmart and get CSR generated from vSmart, sign and upload it back to the vSmart. Everything can be done from the vmanage GUI itself as we just done for the vBond. Let's see how this goes. Here is the vSmart configuration template. Let's start with the host name, location, system IP, site ID is going to be 1, org name is this, and then we don't need DNS at least for this lab topology. And who's the vBond? vBond is 192.168.0.52. vSmart interface is 80 as per our plan, and vSmart IP is 192.168.0.53/24. And I'm gonna just keep it simple by allowing all service, and the next stop should be .50. Let's copy this, get into the vSmart CLI, config terminal, paste it, commit and quit. Okay, let's quickly check the control local properties. Still the certificate is not installed, so the next step is we have to request vmanage to help us in getting a certificate for the vSmart, same way we did for the vBond. Let's do that. Let's get back in vmanage GUI, configuration, devices, and under controllers, add controller. This time it's vSmart. IP is 192.168.0.53. Username, password. I'm gonna remove generate CSR. In case if I do this right, it will automatically generate the CSR. I don't want to do that. Let's do it one step at a time. Let's add this. Yes, successfully added. And let's go to certificates, under controllers. Yes, for vSmart, generate a CSR. Yes, download. You see the CSR is downloaded. Let's close this. Let me navigate to that path. Here we go. Again, the name is undefined. I'm going to change it to be vSmart, and then open XCA. get under this tab, import vsmart, click OK, and then right click, sign this CSR, use this for signing, and then extensions is an end entity, critical this, and 3 apply, key usage, digital signature, key encipherment. Here we have to select all 3 CAs. Nothing in advance, nothing in comment for now. Let's click OK. Yes, signed successfully. Go under certificates. Here it is. Export. Yes. Yeah, I want it to be in this path. Let's click OK. Yeah, you see here the certificate is available now. Let's go back to vmanage, install a certificate, select a file, show me all the files. Where it is? Yeah, here it is. vsmart, click install. Now vmanage will install the certificate into the vsmart. Let that go. Parallelly, let's go to the vsmart and do the command again. Yes, you see certificate is installed now. And if you remember, we have installed the root certificate for the vmanage only, right? How did vbond and vsmart got the root certificate? When we added the device here in vmanage, right? We added, let me go here. We added vbond and vsmart under this devices tab, isn't it? During that time, vmanage will automatically install the root certificate that he have, the enterprise root certificate, right, into vsmart and vbond. So that's an automated process. One final thing, let's check the control connections of the vsmart. We expect control connections to both vbond and vmanage. We have 4 control connections to the vbond. That is because vsmart have 4 cores and he will go and register about all those 4 cores to the vbond. Whereas between vmanage and vsmart, there will be only 1 control connection. Okay, now it's time for us to explore a bit into the current status of our lab network, and also we will quickly validate the same. The controls are brought up successfully. If I get into the vmanage and under configuration certificates, under controllers, we see that all 3 controllers are operational status is vbond updated, installed, and certificate serial number is available, and we'll see an expiry date as well, right? That means they have a valid certificate. Here in the vmanage CLI, if I do a show control connections, we see we have control connections to both vsmart and vbond. Same way, when I get into vbond, we have control connection to both vbond. Okay, so as I told you, it should have been show orchestrator connections. Yeah, we have to both vsmart and vmanage as we expect it to be. vsmart have control connections as well. Let's do this. Here you go. This is the current status of our lab. We'll start off with the edge routers onboarding now. Before we start to bring up the SD-WAN edge routers, we need to discuss on some important topics. Let's start with the discussion about how the different devices are uniquely identified in the Cisco SD-WAN overlay, and also the steps for manual deployment of Cisco SD-WAN edges. We will not be discussing about ZTP, zero touch provisioning feature of Cisco SD-WAN. Again, you can check out our other video series for the same. VH hardwares have the certificate signed by Avnet and burned into the Trusted Platform Module TPM chip. Symantec, DigiCert and Cisco root certificates are preloaded into the software. Enterprise root certificates will be loaded manually, distributed automatically by vmanage, or we also install them during the ZTP process. Except ASR 1002X, all CH hardwares have secure unique device identifier, which is SUDI. This is an X509V3 certificate associated with a key pair that is protected in hardware SUDI chip. Symantec, DigiCert or Cisco root certificates are preloaded in the software. Enterprise root certificates are again uploaded manually, and also we can install it via PNP automatic process. Enterprise root certificates are manually uploaded, or we can use the PNP auto provisioning method as well. VH Cloud routers, Cat 8KVs or Cisco ASR 1002X routers, they do not have a certificate or serial number. So an OTP that is generated by the vManage will be configured during the deployment process, which they will use for the temporary identity. After temporary authentication, a permanent serial number and a certificate is provided to them by the vManage, which they will use to come up in the network as like any other hardware devices. The vManage will act as a certificate authority for Vantage Cloud routers and the ASR 1002X. vManage distributes the Viptela root certificates automatically to vBond and vSmart. After Vantage routers are authenticated using OTP, vManage CA issues them Viptela signed certificates, which will be used by the virtual edge routers to do further overlay authentications. Now let's look at the manual deployment process of a hardware Vantage router, whether it is a VH or a CH. First we'll get into the console of the router, and then we will paste in the basic configurations which we have prepared. If you remember, the router already have a serial number and a certificate built in. So with the serial number, certificate and along with the basic configuration details, he will reach out to the vBond, and once it is authenticated successfully, vBond will share the vManage and vSmart data so that he will reach out to the vManage and vSmart and authenticate as well. Once this step is done, he knows about the other Vanages as well from vSmart so that he can form BFDs, which is IPsec tunnels. Let's see how a virtual edge router manual deployment process happens. There is two steps. One, first, the virtual edge router doesn't have a serial number and a certificate. He needs to get a serial number and a certificate from the vManage. Let's see how that process works, which is step 1. In the vManage, we will generate a UUID and a OTP for this specific virtual router. And then this data will be shared to the vBond as well. Then the administrator will copy the UUID and OTP and get into the console of the virtual Vantage router and paste it in. Also, he will put the basic configuration as required. Once the virtual edge router have this data, he will reach out to the vBond with the UUID and the OTP. vBond will authenticate the OTP, and once the authentication is successful, he will redirect the virtual Vantage to the vManage. Next, the virtual Vantage will go to the vManage along with the UUID and OTP. vManage will authenticate the UUID and OTP. If it is successful, he will assign a serial number, a permanent serial number and a signed certificate to the virtual Vantage router. Now, the Vantage router has a serial number and a signed certificate. Now he is good to start the next level of process, which is forming permanent DTLS tunnels. Whatever tunnels have been formed so far are all temporary connections which will be terminated immediately after this. Now this virtual Vantage router have a serial number and a certificate for himself. In the 9th step, he will reach out to the vBond, but this time the authentication will be based on the certificate and the serial number. Once authenticated, vBond will share vManage and vSmart data, so he will get authenticated with them also with the certificate and the serial number. Once that authentication is successful, vSmart will share the data about other Vantage routers in the network. So this router will establish BFD tunnels, which is IPsec tunnels, to the other Vantage router. So this is how manual provisioning works for hardware router and virtual routers as well. Virtual routers does have some additional steps in which they have to get a serial number and a signed certificate for them. Remember, in our lab, all we have is virtual routers. Whatever we have discussed about this virtual edge manual deployment is a key thing for you to remember, so that it's going to help you to easily follow me when I'm building the lab. In this next section, we will discuss about TLOC extension. This is one of the key features of Cisco SD-WAN. Let's start. TLOC extension is basically an option by which we extend and transport circuit from one router to another router, so that the other router will believe that he have a direct connectivity to the transport. In this example, if you see that manage router 1 only have MPLS link terminated to him, manage router 2 have internet link terminated on him. So now we will discuss in detail how we can extend the MPLS to router 2 and internet to router 1. If you see the diagram, on the left side we have Vantage 1, on the right side we have Vantage 2. In Vantage 1, I do have shown VPN 0 separately and VPN 10, for example, a service VPN which I have shown here. And same goes for Vantage 2 as well. And we do have MPLS and internet transports. MPLS transport is connected to the Vantage 1 on gigabit 00 port in VPN 0s. In a similar way, internet link is terminated to Gigi 00 of Vantage 2, which belongs to VPN 0 as well. Just for this discussion sake, I have numbered this TLOC as T1 and T3 so that it will be easier for me to explain to you. The intention here is this TLOC 1 which is available in Edge Router 1 should be extended to Vantage 2. TLOC 3 which is available in Edge Router 2 should be extended to Vantage 1. Let's start with TLOC 1 getting extended to Vantage 2. What are the steps? First, we will build a interconnect link on VPN 0 between these two routers, which is Gigi 01. Technically, this can be a physical interface, or even you can carve out a sub interface from an existing physical interface between these two routers. Both options should work. And then if you see on the screen, we do have assigned subnet A for this gigabit 01, right? The next step, we will advertise this subnet A into the MPLS cloud. The subnet A may be a /30 as well, right? Moving on, what we will do is we will get into this interface on the Vantage router 1, and then we will tell him that you are a TLOC extension of Gigi 00. So let me just repeat this here. We will get into this interface, right, who is basically going to help us in extending this TLOC. So we'll get into the interface template, right? Technically speaking, when we go into the vManage, we'll do it via template. We get into the template of this interface, and then we will tell that Gigi 00, you're going to extend to the other direction. We will not tell him that you are extending to this so-and-so router and all. We will just tell him that you are going to extend Gigi 00 transport via this interface. That's it. And then on Vantage 2, what should we do? On Vantage 2, we don't do anything. We'll just go ahead and configure this interface as transport 2, which is basically the same color as this transport 1, right? What this Vantage 2 believes is he have a direct connectivity to MPLS. That's what he believes. And also we do add static routes as necessary, or it may be a routing protocol as per the design. Vantage 2 believes that now he have T3, which is internet, and he also have a link to MPLS, so that when there is some traffic on the LAN side, he is ready to load share it via both the circuits. Obviously, when he puts some traffic on this T2, it's physically going to go via Vantage 1, but Vantage 2 is completely unaware about that. Now remember, this whatever we have done is an MPLS extension, basically private color extension. Now what we are going to do here on the other end is we are going to extend a public color. So there is two challenges in internet extension. One is we have to pay for the WAN IP subnet, which is going to be a public IP, right? So when we extend it to the other router, so basically we have to create, similarly we have to create extra interface. For that interface, we need a public IP as well, right? Generally speaking, but that is not the case. We can assign a private IP there, and then when the traffic goes out, we can ask the router to NAT it to the IP address on Gigi00 of Vantage 2. So let's see how that works. That is just to save public IP space, but technically you can even assign a public IP address without doing that. We will create a link between VPN zeros of these two routers, and in this example I have assigned subnet B. Think of subnet B as a private IP, right? And then we will enable NAT on Gigi00 interface on Vantage 2. Then we will get into this router interface, right? Vantage 2, this particular interface, the one I'm highlighting, and then we will tell him that you should extend Gigi00 into your other direction, right? So that's where we'll do TLOC extension, and then we will go into Vantage 1. We will configure this end of the interface as transport interface, which is basically with a public color same as T3, right? And then obviously we'll add a default route as we require. Now Vantage 1 believes that he have T1, T4, which is a private color, and also he have a public color, which is MPLS and internet connection. This is how both routers believes that they have direct leg to MPLS and internet, but in reality Vantage 1 have to go through Vantage 2 in order to use internet. Same goes for Vantage 2. When he wants to use the MPLS, he should go via the Vantage 1 physically. But each router is completely unaware that they are traversing via the other router in the same site. Let us start to bring up the SD-WAN routers in data center and follow that up by configuring all LAN components as well. The core switch, end host, whatever I have, let's do everything there. Before we start, in Cisco SD-WAN, everything is template driven. There is two types of template, one feature template and another one is device template. Feature template is nothing but, say for example, if you have OSPF, EHRP or an interface or the VPN1 routing table, right? For every set of pieces, we will create a separate feature template. Say for example, for the DHCP or for the NTP configurations. For each of them, we will create a separate feature template and then we will bind everything into the device template. Then this device template will be the one which is getting attached to the edge routers. So when we want to bring up the data center routers, obviously we need to create multiple feature templates. Let's quickly see what are the feature templates which are required to bring up our data center site. Here on SD-WAN router 1, we have the gigabit 1 interface connecting to MPLS, gigabit 2 on SD-WAN router 2 connecting to internet, and as well as there is a TLOC extension which I am going to do between these two routers, and there is two LAN interfaces, one which is going to connect for VPN 10 end host and the other one is for VPN 20, same from edge router 2 as well. So for everything we need to create a separate feature templates. So let's see what are those. To start off, we do have the system template. This is a global template. This basically carries the details of site ID, system IP, org name. Those kind of details will be carried in this system feature template. So what I mean by new is there is reusability, right? The bigger advantage of using template model is reusability. So since this is the first thing which we are bringing up in the network, and this is the first time we are creating system template, we are going to create it as a new. Maybe for the future sites, no need for us to create again, we can reuse this. So that's why I mentioned new. Whenever I mention new, it's something new which we are going to create. Followed by that, we will create a AAA template for authentication. BFD, this is where we will give the values which is hello and the multiplier values. Security template where we will define security parameters, and OMP template, OMP parameters, and we are going to do a banner as well. Followed by that, we will create a localized policy where we will enable DPI and CFlow. This is just to enable the router to do deep packet inspection. Followed by that, we will create a VPN 0 template. This template is just for the VPN 0. You can think like for VRF 0, we are creating a separate template. If you're not able to follow that clearly about these templates, don't worry, we are going to do things together in the lab demo. I hope that will make things clear for you. Followed by that, we will create a MPLS interface template. If you see, we do have a MPLS interface in our design. So we need a MPLS interface template and then an internet interface template. And we also need a TLOC extension interface template, right? Who is going to extend the TLOC. All these templates will go under VPN 0. I'll show you that as well. And we will create a parent interface template. What is the parent interface? Basically in Cisco SD-WAN, the thumb rule is that the main interface from where the sub interface is carved out should always have an higher MTU than the sub interface. It should be at least 4 bytes higher, right? Say if you have a gigabit 1 and you carved out gigabit 1.100 sub interface. So in this case, gigabit 1 can be 1504 and gigabit 1.100 can be 1500, or you can make gigabit 1 as 1500 and keep gigabit 1.100 as 1496. Either of that work. The only rule is the sub interface should be 4 bytes lower than the physical interface. To achieve this and also to create the main interface for the sub interface which we have between the two routers. If you see the diagram, we do have sub interface gigabit 3.100 and 3.200. So obviously we need gigabit 3 interface, right? The main interface created on both the routers. So for that we will use this template. And then we are going to create VPN 10 template, right? That's the service VPN template. And in that service VPN, we have one LAN interface. And also, if you see the diagram, we are going to enable OSPF. For that, we need a separate template. Plus, we need a VPN 20 separate template, VPN 20 LAN interface. And if you see the diagram, I'm going to enable VRRP on VPN 20 interfaces between the two routers. So I'm going to create a separate VRRP template. And finally, we are going to create a DHCP server template. If you see the diagram for the voice phone over there, I haven't assigned an IP address, rather I just mentioned it as DHCP. So he's going to get a DHCP IP from the router who is going to act as a DHCP server. So for that we need a separate template. In vManage, let's navigate to configuration templates, and under feature templates, let's click add template. And then the device version in our lab is cat 8kv. So let me select that. The first one which we are going to bring up is a system template. Let's click and then we'll name this as Cisco system. Or we can make everything in small letters. System. Anything should be fine. Let's name and give a description. Site ID, it's going to be device specific. So there is two values if you see here, global and device specific. When you select global, wherever the template gets assigned, this value will be pushed. And if you select it to be device specific, when you assign this template to a device and attach the template, right, the device template, that is when the vManage will prompt you to fill the value for this device. So we have kept it to be device specific. It will prompt us to fill the site ID when we attach the device template to the router. System IP, let it be device specific. Overlay, if you see this, there is third option which is default. Say there is always default parameters for our Cisco routers, isn't it? Say by default OSPF timer, hello timer, there is values, correct? So if you leave this to be default, it will take the default value. Same way time zone, by default it's UTC. We are going to change it globally, right? So we'll have the same value everywhere, so it's better to keep it global. So let me pick our time zone. Yes, Asia Kolkata. Host name will be unique for every router, so let it be device specific. Location, let it be device specific as well. Device group, controller group, we are not going to touch those things for now. Console baud rate, I'm going to keep it to be 9600 for every box, so that's why I'm putting it as global. Lat long, I'm not going to be doing that, but in case you are doing this in production, you may need that. Tracker, we don't need a tracker, at least for now. Port hopping, port offset. Okay, so as per Cisco guidelines, we need to enable port hopping in branch locations, whereas we should disable it in the hub locations. So I'll keep this as device specific. If we are pushing the same system template to a branch and a data center in our lab topology, I will turn this on in the branch, whereas I will turn it off in the data center. Port offset, track transport, other things I think are good. We can save this. The next template which we have planned is, let's click here, again select. So template creation is a little hectic process, but remember it's always one time, right? Think about 1000, 2000 sites which you may have in your production, right? You can restrict it with maybe 10 to 15 templates depending on the design or the way you plan it to be. Let's give the template name as Cisco AAA, and then I'm going to only use local credentials. So let me create a local credential. I'm just changing the default password here. The default password is always admin. I'm changing it, and then if I go down techax .1x, I'm not going to do anything. I'll go here and then I will add the authentication order to be local. So that's the only option because I haven't created techax or radius. While if I create one, it will show the techax or radius as well here. Okay, let's save this. Next one, BFD. Let's create that. Cisco BFD. Cisco BFD. I'm going to leave this multiplier polling interval. These are all things related to the loss latency jitter which is captured by the SD-WAN edge router. Let's move down for color. Say we are going to have two colors in our network, one for MPLS and one is public internet. So let's choose MPLS. Let's leave the hello interval for the BFD tunnel to be 1 second and multiplier as 7. Let's leave it to be default and say add. Even if you don't do this template, it's going to take the default value, but I just wanted to show you this so that you can do this if you need, right? So just in case if you are playing around with the BFD values, hello interval and multiplier values, you would have changed that as well. But in my lab, I'm not going to do that. I'll just keep it simple. So I have two colors, right? So whatever you see here on the bottom, this is for the tunnel, hello and multiplier, whereas the top one is related with the loss latency jitter parameters, which is captured by the Cisco SD-WAN. Let's save this. Add and 8000 cat 8 kV, and then let's select OMP now. Let's name it as Cisco OMP, and I'm not going to do anything. Okay, graceful restart timer is say for example when you have lost your control connections to all the controllers, still the edge routers can survive on their own, right? They will not drop the IPsec tunnels which they have at the other sites. So how long they will retain the routes in the routing table will be based on the graceful restart timer value which you are going to set. By default, if you see, it's 43200 seconds, which is 12 hours. Let me show you. If you see, it's by default 12 hours. What we can do here is, let's do this, why not? Let's change it to be 1 hour. Okay, again, this value is purely dependent on the customer. It's mostly based on their complaints or how long they want to retain a site when the control connections goes down. So those things will define this. And in the theory section, I have told you about how many prefix should be advertised and what's the ECMP limit. I'm going to change it to be the maximum 16. If you see here, if I make it 17, it's showing the maximum allowed is 16 only. So I'll keep it to be the maximum. So this template is going to get attached to the edges. When we change this, right, we should change this in the vSmart as well. We should take care there. Okay. So in our lab as well, we should go back to the vSmart and change this value manually there. Let us, I'll not do this shutdown, that's not needed. We'll not shut down OMP at any case, as I know. Timers, I'm going to leave that to be the default. And then these things will come back when needed. Yep, I think we are good here. Let's save. Let's add template 8000 Cisco security. Let's give it a name as Cisco security rekey timer. So by default, the thumb rule is the rekey timer should be at least twice the graceful restart timer. So if you see here, we had the graceful restart timer as 1 hour, right? We reconfigured that. So the rekey timer should be at least 2 hours. It should not be less than that. Okay, that's the Cisco recommendation. We'll go ahead with 2 hours only. So we'll change this global 7200. I'm keeping this as global so that it gets pushed to all the routers to whom this template is getting attached. And the authentication type, I'm going to leave it to be the default, and keychain those details as well. So let's save. Next one, add template, search 8000 again, select this. If I go down, we'll see Cisco banner. Let's do that quickly. Yep. So let's name it to be Cisco banner. Change it to be the global variable, save, and then keep adding 8000V. Just 1 minute. If you see, right, in case if you have multiple types of CHs, say example, if you have an ISR as well, right, you can select that too, right? You can select 2 edge routers at the same time and then create a template for that. Even if you don't do this now, you can add it later as well. So let's quickly move to creating the VPN templates now. So this is going to be Cisco VPN 0. And then the VPN number is 0. I'm going to give that a name as transport, right? And if you need DNS, you can add here. But in my case, I need a host mapping because if you remember, we have given FQDN for our vbound always in our design and then resolved it to an IP address. So it's going to be lab.vbound.com and then the IP will be 192.168.0.52. Add it, go down. Under IP route, if you remember, we do have 2 WAN transports. So I'm going to add 2 default static routes pointing to the next stops of each of the ISPs, which is MPLS1 and Internet1. What I'm going to do here is I'm going to make it an optional row. Let me do this on first. Say I'll change this key value so that when it prompts you, right, it will prompt you with this key value. So even you will be able to understand that easily. I'm going to add as prefix 1. Let me copy this. Now select it as optional so that even if you don't fill a value for this variable, it's going to allow you to push the configuration to the edge router. So that's the optional keyword. And then let's add a next stop to this. Add next stop, and then the next stop is, scroll down, VPN 0 next stop for prefix 1. Okay, and add. Let's add again. This is 1 prefix and I'm expecting a maximum of 2 prefixes in VPN 0. So I'm going to add 1 more. This one will be VPN 0 IPv4 IP prefix 2. and then it's going to be optional as well. Next stop VPN 0 prefix 2, add and nothing else for now. Let's save this. Then let's quickly do this. Let's quickly create VPN templates for VPN 10 and 20 as well. So let's select 8000. Let's again click the same Cisco VPN template. Here let's name it as Cisco VPN 10. Go down. The VPN ID is going to be 10 in this case. Name of this VPN will be data VPN. That's our plan, right? And then go down. We don't need a host mapping here. Host mapping is needed in VPN 0 only. Yes, IPv4 route. If you think in our lab design, we are not going to add any static routes in VPN 10 at all. We will be having OSPF running on the VPN 10 LAN side of the data center, and then on the branches it's actually directly connected, so we don't need IPv4 route in any of the cases. So I'm going to skip that as well and just keep going. Yes, save, add template 8000 cat 8 kb and click this again. Now for VPN 20, let's name this as Cisco VPN 20. Copy, paste. You can give the description in a more granular way. I'm just keeping it simple. Okay, and the name in my case is voice VPN. Going down, I don't need a DNS entry, and here as well, right? If you think in data center we are going to run VRRP, and it's a directly connected thing in the data center as well as in the branches. If I go down, I don't think I need anything else. Let's just save this. As we discussed, we have to create a template for MPLS interface, internet interface, and also the parent interface and TLOC extension interface as well. As I already told you, don't get too much stressed with this number of templates we are creating. It's going to be one-time effort. Let's click Cisco VPN interface template. I'm going to name this as, I'll show you the easy ways as well, right? I'll take copies and then I can reuse the templates. Just edit and reuse, right? Cisco VPN 0 MPLS interface, and then if I go down, I need option to turn off and turn on the link, so I'm gonna do shutdown as device specific, and then let me copy this, and the interface name also may change in some case, but in case if you're doing this in your production, right, it's preferred that say you keep the same interface number throughout so that you can reduce the number of templates, and you can make it global, right, to keep it simple, and you can restrict your operations team from doing any mistake or changing the interface from your initial plan. And then the IP address, it's going to be a definite device specific one, VPN 0 MPLS IPv4, and if I go down, yes, it is a tunnel interface. Let's turn that on. You will see new options popping up. Yes, and the color I'm gonna set it to be, we decided it to be MPLS, right? And restrict. What restrict does is it will create tunnels only between the similar colors. Say example, if I have MPLS and there is one more color called private one, right? So Endpoints will form tunnel only between MPLS to MPLS and private one to private one. It will not form tunnels from MPLS to private one. Okay, but by default, if you don't do this, it will try to form even though he doesn't have reachability. That's the default behavior of Cisco SD-WAN. And maximum control connections. This is a catch here. If you remember our topology, in MPLS, I don't have connectivity to the controllers at all. So the thumb rule of Cisco SD-WAN is only when you have control connections up via a specific T-lock, you go ahead and bring up BFD via the T-lock. To override that thumb rule, we have to instruct the router that don't expect control connections here, so that the router, even though he is not able to form control connection, he will go ahead and form the BFD. If I don't do this, the MPLS interface in our lab topology will always wait for the control connections to come up, and obviously it will never able to establish control connection, and then finally it will not bring up the BFD as well. So I have made it 0. Let's keep going here. Port hop on, and yep, service. I think we'll leave it to be default. Say example, in case if you are bringing BGP with your ISP, then you should turn this on. Then only the BGP neighborship will come up. So in our case, I'm going to leave that as default. And then under advanced option, I'm not going to do anything for now, right? You see here the hello interval and hello tolerance are also available. In case if you want, you can tweak that as well. And NAT cannot be enabled on private colors, obviously. And if I go down, I'm not going to do anything else. I'm going to save this. That's it. The next step is, let me take a copy of this MPLS. Rather than creating a separate new internet interface template, I'll just take a copy and then just quickly edit this, because most of the values are going to be same. Copy, and let me search for int. Here you go, this is it. Let me edit this a bit, right? The name doesn't seem proper. Let me rename it as internet, so that we read that properly, right? Okay, go ahead, go down. You see, all I have to do is just change this keyboard from MPLS to internet. Copy this. Interface name is going to be device specific. Okay, there's a typo there. Hold on. Internet. IP address. I'm just going to keep. Go down. Here you go. So it's a tunnel interface, but the color is public internet as we decided. Restrict is going to be on. Control connection, I'm setting it as default because we expect control connections to be up via the internet. And then if I go down, I think I don't need anything else. Yes, I think we don't need anything. We'll just go ahead, update. Now we have to do TLOC extension as well in the data center. Let's create templates for that as well. Let's name this as Cisco VPN 0 TLOC ext interface. I think we need only one interface. We can reuse the same template for both the routers. That should be okay. So let's name this as VPN 0 TLOC extension interface, right? Let me copy this interface name, description. Let's give him a description as well, and then IPv4 address is needed as well. Go down. It's not a tunnel interface, remember, it's a TLOC extension interface. Okay, so it's not a tunnel interface, obviously. Let's keep going. Let's go to the advanced section, and then here you see, right, TLOC extension. This is where we have to tell him which interface he is going to extend, right? So we'll keep it as device specific so that we can define it when we push it to the edge router. That's it. Let's save. And the TLOC interfaces are planned to be sub interface. So there should be obviously a parent interface for those sub interfaces. So we need to create a parent interface template. Cisco VPN0 parent int. Okay, one more catch here, the parent interfaces will always be under VPN0, right? Say example, if you have gigabit 1 and you segregate it as gigabit 1.100 and 1.200, and you assign 1.100 to the WAN side and 1.200 to the LAN side, still the gigabit 1 interface should be configured under VPN0. Okay, VPN0 parent interface. Let's just keep it simple. Interface name. All we have to do with the parent interface is just unshed that, right? If you remember, when you are creating sub interface, we don't generally configure IP address under the parent interface, right? So I'm gonna leave this as default. Only I'm having option to turn on that interface and a name and a description. That's all. I think we are good for this template. Let's save that. Okay, that's my bad. There is an important factor which I missed. Let me go back to that parent template. The MTU, if you remember, I already told you that the MTU of the parent interface should be at least 4 bytes more than the sub interfaces. So if you remember, I haven't tweaked the MTU on the other templates which I created, which I'm going to use for the tunnel interfaces, right? So my plan is increase the parent interface to 1504 so that I can leave the sub interfaces in 1500. Next one, we have the LAN interfaces. Let's start off with the VPN 10 LAN interface. Same template. Let's name this as Cisco VPN 10 LAN int1. Copy paste. Go down. I'm gonna do this as device specific VPN 10 LAN inf. That should do. Interface name, a description, and it will have an interface IP as well. And going down, I don't think we need anything else. So we can just save this. And then what I'm gonna do here is, let's search for this VPN 10 LAN interface which we created and take a copy. We'll use this for VPN 20. This is how you can save some time by taking copies and just quickly editing it. Let's edit this. Yep, name is good. I just have to edit the keys. The keys should be saying VPN 20 rather than VPN 10. Let's change everywhere. That's it. Let's update. And then I'm going to take one more copy. This is needed for the VRRP template. Okay. So VPN 20 LAN interface 1, say example with VRRP. Copy, paste, copy. Let's edit this now and go under this section. New VRRP. Group ID, I'm going to set that to be 10. And priority, I'm going to keep it as device specific so that you can use the same template to both the routers and set a different priority. Sorry, it's VPN 20, right? VPN 20 VRRP priority. Timers, let it be default, and there is options to track OMP prefix list, right? We are going to keep it simple by tracking the OMP. So when the OMP goes down, the VRRP will be down as well. And this is the IP address, VRRP VIP, right? Virtual IP. VPN 20. You don't need anything else. Object tracker, we are not gonna do those things, at least for now. Yes, we are good. Let me add this. Update. The next thing is, if you remember, I told you that the voice phones are going to get IP address from DHCP, right? We are not going to configure them static IP. So we have to create a DHCP template as well. Let's select this, search for DHCP. Here we go. See DHCP. DHCP. Always remember, this one template can be reused multiple times. Address pool, I'm gonna keep it device specific. No, let's not do exclude address and all. Let's just have a address pool, and then I don't need any options. Gateway interface MTU, domain name, yes. I need a DHCP. I need a default gateway to be sent, right? And DNS servers. I don't need these things anyway. We are going to just validate with pings. We are good here. If you need, you can definitely use these options, but just for my lab, I don't think I need those things. Let's click add template. The next one is OSPF. So we are planning to enable OSPF on VPN 10 in data center, isn't it? We'll do a OSPF template as well for that. Cisco OSPF. Cisco OSPF. Yep. Router ID. I'm not going to do any router ID and all. If in case you need, you can do that. And in OSPF, we will redistribute our OMP. Say if you think in the data center, we are going to have OSPF on the LAN and OMP is the protocol which is on the WAN side, isn't it? So we have to redistribute the routes from OMP into the OSPF, and we also do in the other direction. So now I am inside OSPF, which is similar to being under router OSPF 10 or router OSPF 1, whatever it is, right? And then doing redistribute OMP. That's what I'm trying to do with the template. So just redistribute and add. Yep. New area. Let's keep it to be 0, and I don't need any type for that area. Let it be the default one. And interface, OSPF, let's make it a little bit understandable. OSPF interface name, and hello interval. I don't need to tweak this. Interface cost, let me think for a minute. Do I need the cost or no? Yeah, I think I need the cost because From the core switch perspective in the data center, I may have to make sure that I'm choosing the primary router, right? So for that, I think I need the cast. Let me do that as well. And if I go down, advanced option, let's do this. Let me change it to be point to point so that it comes up quickly. I don't need authentication. I don't want to complicate this. So, yep, in data center router 1, there is only one interface where we need to enable OSPF. So I think we are good here. Let's save this. And it's going to come up on area 0. This should be fine. And I think I have 1 gig as well. So the maximum I have is 1 gig. Let's keep it 10,000, 10 gig. Do I need to originate a default route? No, that's not my requirement. I think pretty much that's it. Let's do this as well. Why should we leave this? OSPF router ready. Save. Yeah, we are good. We have created almost all the templates which are necessary to bring up the data center SD-WAN routers. We'll see if in case we have missed something and we identify when we bring up the edge routers, we'll come back and create them. And if you remember, when we created the OMP template, I have changed the advertise and ECMP limit to be 60 in the maximum. That time I have told you that we should do the change in vSmart as well. So let's quickly close that. Let's go to vSmart. We have to get into OMP. Send path limit. You see, by default it's 4 and it can be between 1 to 16. I'm gonna set it to be 16 and also I'm gonna add send backup paths as well. Commit and quit. We are good here. Now let's quickly prepare basic configuration file for data center router 2. We are going to bring up data center router 2 first, because if you remember, we have the controllers sitting only in the internet, and the data center router 2 is the one who actually have internet connection directly, right? Whereas data center router 1 have internet connection, but it is actually via the data center router 2. It's a TLOC extended link which the data center router 1 have, right? So we should bring up data center router 2 first. Here is the basic configuration template which I have already created for the data center router 2. Config transaction is the command equivalent to config t in Cisco SD-WAN. Host name, username, and we are also setting the clock time zone. The system IP which I have decided is 10.1.101 for DC router 1 and 102 for this DC router 2. And for data center, the site ID which I have decided is 100. Org name is going to be this, which we already know. vbondlab.vbond.com, and the next stop is 201.11.1.1 if you look at the diagram. And who's the vbond? 192.168.0.52, and gigabit 2 is the one which is connecting to the internet, isn't it? His IP is the same subnet .2, it's a /24. And we are going to create a tunnel interface and use this interface as the source, and the tunnel mode is SD-WAN, and under SD-WAN we will declare the color of this interface to be public internet and encapsulation as IPsec. This is pretty much it. This is the basic configuration which we need to bring up DC router 2. Let's get into the DC router 2 quickly. If you see, DC router 2 is currently up, but when I do a show version, pipe include mode, you see, hold on, mode, you see the operating mode of this router currently is autonomous. So in latest versions of Cisco SD-WAN router, the router first comes up as a regular iOS router, and then we have to enable that router to be SD-WAN capable. How do we do that? We do controller mode enable. When I do this, the router will go for a reboot and then come up as SD-WAN enabled. One more thing we can do to validate quickly is show SD-WAN. If you see, this command doesn't work in normal mode. So let's get this enabled. Oops, my bad. No. Okay, the router went for a reboot. Let's wait for some time. Meanwhile, what I'm going to do is I'm going to enable all other Cat 8kV routers in controller mode. DC router 1 and the branch 2 router. So let's do that. DC router 1, enable controller mode, enable. So let them come up as well. Branch router 2. Yep. Controller mode enable. So when we are in that section, they will be ready for us, just to save some time. Okay, I'll pause here and then we'll come back when the router is up in controller mode. Okay, I can see the router have rebooted and came back online. Let's try getting into the router. Yep, the default username password is admin, and once you do that, it will prompt you to set a new password, admin, and then I'm setting a new password. Yes, we are in the router now. Yep. Okay, so do a show SD-WAN. You see, now we are having this show SD-WAN command. Let's quickly do show version pipe include mode. You see, it's in controller mode. To onboard this router in Cisco SD-WAN overlay, the first thing is we need to install the enterprise root certificate. Because we are using enterprise EA model in our overlay, we need to install that manually. Otherwise, if we are using a Cisco or DigiCert or any other model, those root certificates are already pre-populated into the router. Before doing anything, let's check this one quickly. Show SD-WAN control local properties. And you see the certificate status is not installed. Let me show you one more thing. Show SD-WAN certificate serial. Since this is a virtual router, we don't expect it to have a serial number also. This chassis number is a random built into the edge. We'll change this as well. Okay, let's start with installing the root certificate. If you see here, let me show you this. Show SD-WAN certificate, root certificate pipe include. I'm just trying to grab some specific lines from the output. It's a very big output, so we'll not be able to see that completely. So I'm just trying to do this. When I do this, I don't see that root certificate at all with this keyboard, right? So what I'm going to do is I'm going to install that root certificate first. For that, I have already copied that root certificate into the boot flash of the router. You see here, I have the lab root certificate available in this router already. What I'm going to do now is request platform software SD-WAN certificate install. No, I think it's SD-WAN root cert chain install, and it is from boot flash. The name is lab root cert. Enter. Yes, the root certificate is successfully installed. Let's do the same command again. You see now there is some lines which dictates that the certificate is installed into the box. The next step, let's get into the basic config. Copy, paste it in. Not sure whether it got pasted successfully. I think it just went into the config mode. I haven't pasted anything. Let's do section by section just to be on the safer side. Yeah, good. Commit. There is issues. Why the host name haven't changed? Let's check that. Okay, I think I missed to paste this host name thing. Let me do config transaction again. Go back to this template. I started copying from this. I should have done this as well. Let me copy, paste them in, commit. Yes. Now we have the basic configuration pasted into the router, and also we installed the root certificate, which is the enterprise root certificate. If you remember from our theory sections, we need to generate a OTP in the vManage and provide it to the router so that the router will reach out to vBond and vManage with that OTP and then get a signed certificate from the vManage allocated to him. Let's get back to the vManage and let's get into devices. Now under the vanage list, there is no vanages listed at all. For this, there is two options. Either we can sync with our smart account or we can upload the vanage list manually. We are going to do the manual way now. Let's click this. Let me navigate to this file under SDWAN. I think I kept it here. Here you go, right? Let me click this so that it will share this data with the other controllers as well. Upload. Okay. You see there is 6 routers available, which is successfully installed here. Let's go back, devices. Now we have the list. Let's click here on a 8 kV, it can be any one, and then click generate bootstrap configuration. And here you have to select cloud init, keep it cloud init, and you see here there is a OTP and a UUID generated. OTP is the one-time password which we are going to give to the router, and this is the chassis number which the router is going to use. Once the router reaches to vManage will assign him a serial number and a certificate. Let's copy this UUID first, get back to the router. Before I paste this, let's quickly validate the main thing, which is reachability to the controllers. 52 is vBond, 51 is vManage. Obviously everything is in the same subnet, it should ping. Yep, all are pinging, so we can start this process. Request platform software SD-WAN VH cloud activate chassis number. That's the UUID value which you copied from the vManage GUI, and then now copy the OTP, and the keyword to give the OTP is token, and then paste the OTP, enter. Just give it some time so that first the VH reaches out to vBond and vManage, get a certificate, and then turn down the connection, freshly initiate new connections established with the controllers. It should take some time. Let's give it some time. You see, there is already a log message stating that he reached up to the vManage. If in case you are in a console and whether it is hardware or virtual router and you are looking for a log message which will give you an identification that the complete process is done, right? It's the OMP come bring up message. So the process goes like this: the control connections forms to vBond first and then vManage and also to the vSmart. Once the control connections are good, then the OMP gets established. So when you see OMP up, that gives you a clear idea that most of the things are ready, right? We can do a show SDWAN. Let's go to the vManage. Here you see the current state is a certificate installed. So vManage have done his part. He have given him a certificate already. We can check the same in router as well. Show SDWAN, control local properties. You see a certificate is installed now. Let's quit, and then this is what I was talking about. There is a vSmart OMP connection up. This gives us a clear idea that the router is ready. So let's quickly do a show control connections. You see, we have a vManage, vBond, and vSmart. And if you would have heard that vBond is a temporary connection, yes, it's true, but it depends. Say, if we had one more vSmart in this network, then the vBond connection would have been bent down immediately after the vSmart came up. Since we have only one vSmart, you will see always the vBond connection also up. Let's quickly check show SDWAN OMP peers. Yes, OMP is also up now. Get back to vManage and then under. Now here in the vManage, right, we should create a device template. This is the template which will get attached to the edge router. Let's click from feature template, and the model of the router will be this one, C8000V, and the device route is SDWAN edge. Template name, I'm gonna keep it to be DCRT1. As a general practice, I always keep the data center routers in a separate template, whereas for the branches we'll try to use the same template as much as possible. So let's create one template for the DC router. Oh, okay, it's DC router 2 now, correct? And then the system template which we created. Logging, we haven't done any logging, and no NTP. Yes, we have created a AAA template. This is that, and we have a BFT of our own, and we also created a OMP template. Here it is, and also we created a security template. I'm just calling the feature templates which I have created earlier, right? It's so simple. And then we are going to have a VPN 0. And there in VPN 0, I am going to have one MPLS. Let me search for that. Here it is, MPLS, and then I have to add one internet as well. Plus, there is a sub interfaces in edge router 2, so I need one parent interface, and then if you remember, we have to extend this internet leg from router 2 to router 1. For that I need a TLOC extension interface. So I'm going to select TLOC extension interface, and there is no routing protocols which I have, right? I have only static route which is called under this VPN 0 already. That should be enough. VPN 512, I'm going to leave it as default. In some cases, it asks you to create a template for VPN 512. I have seen that for some specific routers. I hope this should be fine. If in case it's needed, we'll come back and create. Okay, now under VPN, we are going to add VPN. First, we are going to add VPN 10. Let's click next. Okay, I should move this to this side and click next. And in VPN 10, in the data center, I'm going to have one LAN interface. Let me search that. Here it is. And then I'm going to have OSPF enabled there. Right? Save and click add VPN again. This is for VPN 20 now. Select that, next, and in VPN 20 I'm going to have only one interface, and this time that interface is going to be a one with VRRP. Let's select and add. Let's keep going down. Cellular, additional templates. Yes, I have a banner which I'm going to use, and policy. Let's come back to this policy quickly. So just keep an eye on that. Let's create this. If you remember, we have discussed that we will create a localized policy where we will enable DPI and CFlow, right? When we are talking about the templates creation for data center. Let's do that now. Let's go to config policy, under localized policy, add policy. Skip all these for now. Let's go to the last page, enable NetFlow and application visibility, and I'm going to name this as localized policy. That's it. Simple for now. Save. Only when you do this, the router will start capturing the DPI statistics. Let's edit this again and go under this additional templates. Now here in policy, if I click drop down, you see that policy which we have created. Select that and update. And we noticed from the router CLI that we are able to successfully establish the control connections, isn't it? Same way in the GUI, if I go under network, we should be seeing DC router 2 there as well, right? Now let's quickly move on to the templates, and now I'm going to attach this router, the template. What configuration we have done so far in the router is just pure basic configuration. I just configured, informed about the internet interface of the router, right? Apart from that, the router doesn't have any other configuration. So when I attach the template, he's going to get details about the VPN 10, VPN 20, the TLOC interface, MPLS interface configuration also will only get pushed when I attach the template. I haven't done that in the basic configuration at all. So we must attach the template now. Attach device, you see DC router 1 pops up, and attach. You see this gray mark, this should turn green. That's when you are allowed to move to the next page. So for that, we have to fill up the values for the variables, if you remember, which we done when we are creating the templates, right? So you see, this is how it asks you for filling up the values. First, it's ask you for filling up VPN 20 LAN interface name. What's your VPN 20 LAN interface? It's gigabit 6, right? Let me do one thing quickly. Let me pick this name. Yes, copy. And VPN 20 as per our plan is gigabit 6. And I'm going to keep the descriptions simple. VPN 20 LAN. And the IP address as per our plan is 10.122/24. And yes, the priority for router 2, let's make router 1 as primary, so that I'll keep this as 90. When we bring up router 1, I will give 110 there. Okay, 110. IP address, virtual IP for VRRP is .1 as per our plan. Interface name for VPN 10 now, I think it's gigabit 5. Description is VPN 10. Plan IP address 10.1.1.1/24. That's my plan, and I have to enable OSPF there, isn't it? So let me keep the router ID same as the interface just to keep it simple. And OSPF interface name, how to enable OSPF on gigabit 5, and let's keep the cost as 10 here. We'll do the same on the second router. We'll do 20 there, right? So that we'll prefer this. And now in VPN 0 we have created 2 prefix lists, right? So I'm going to have 2 default routes in the VPN 0, 1 and 2. You see, this is optional. Say if I remove this, you see that even you can skip that. That shows an optional keyword there, right? That is what happens when you enable that optional tab that I have showed you in the template creation steps. Now the first next stop is 200, no, my bad, 201.11 and 1.1. that's the internet next stop. And the second next stop for VH router 2 in data center is the VH router 1, because MPLS link is extended from router 1 to router 2, right? So he should point a default route back to router 1. That's how it works. Now let me add this next stop. The next stop is 10.10.10.1. If you see in our diagram, this is gigabit 3.100 interface. Followed by that VPN 0 TLOC extension interface. Who's the one extending the TLOC, which is internet TLOC from this router to the router 1? As per our plan, gigabit 3.200 is the interface who is going to extend internet TLOC. And then VPN 0 internet TLOC extension interface. And the IP address we have planned is 201.11.10.1 subnet mask /24 TLOC extension. This is the point. Who are you going to extend? I'm going to extend gigabit 2. So gigabit 2 is the internet TLOC interface. I'm extending that interface via gigabit 3.200. And then VPN parent interface. Yeah, as I told you, we have to create a parent interface for this gigabit. You see, gigabit 3 sub interface we have created now. So for that we have to create a parent interface. That parent interface is going to have just a description and a shutdown option. That's it. And then for VPN 0 internet name, now this is for the internet interface. Let's do, I think it's gigabit 2 description VPN 0 internet interface, and the IP we have planned is 201.11.1.2/24. VPN 0 MPLS interface in our design is 3.100. That's the TLOC as per VH router 2, but actually it's getting extended from router 1, but VH router 2 is not aware about that. He just believes that he have a direct connection to MPLS. Copy, paste, just rename it as MPLS. IP address which we have planned is 10.10.10.2/24. and the host name for this box is DCRT2. Location I'm going to give us system IP we have planned is 10.1.1.102 if I'm not wrong. Site ID 100. I'm not going to enable port hopping here. Yes, I think this should be fine. Let's update. You see, now it's green. What I'm going to do, I'm just going to take a backup of this just in case if I want to refill this, I don't need to type everything again. So let's click next. Let's click here. This will give us a configuration preview, and also we can see the configuration difference between the configuration which we are going to push and the configuration which is already available in the box. Next, if you see here, this is the config preview. This is the configuration which is going to get pushed into the box, and we can also see a config diff side by side diff. You see, this is the current local configuration on the box, and this is the new configuration. Since this is the first time I'm pushing configuration to this box via template, you will see lots and lots of changes. But in case if this is already pushed and you are doing some operational change, you may see very few lines difference between these two. Let's push this. And before I do that, you see this configure device rollback timer. So when I push this template, if the control connections goes down within 5 minutes, after 5 minutes to be exact, the vManage will roll back to the last good known configuration, right? And then come up. So let's configure. Let's give it a couple of minutes. Okay, you see now the template is attached successfully to the router. We can quickly go to configuration devices, and then from here you can see that if I scroll to the right, the first router 10.1.1.102 have a template attached. Where it is, yeah, here assigned template DCRT2, that's the template name attached to that. So this gives us a clear indication that which routers have templates assigned which are in CLI mode and all. Let's go back to templates. Okay, here if you see devices attached, when I click that, it shows that DC router 2 is attached to this. What we are going to do now is we brought up DC router 2 in a way that we first configure the CLI, and then the router comes up and joins the vManage, then we push the template. Instead, we'll first create a template and then attach it to a serial number. Followed by that, we'll go ahead and do the basic configurations needed on the DC router 1, so that when DC router 1 comes up and joins the overlay, that is the vManage, he already have a template ready for him to consume, right? So we'll see how that model works now. Let's start creating a template for DC router 1 from feature template. Select model, get the 8 KB. Device model, SDWAN edge, template name DCRT1, copy paste, same system template. You see, I am using the same feature template for multiple device templates. This is the beauty of templates. AAA, BFD, OMP. Now think from VH router 1 shoes, right? What are the things he have? He have a VPN 0, and he have one directly connected MPLS interface, and then he also have a internet transport, but it is extended from VH router 2. But obviously he is not aware about that, so he believes that he have an internet transport as well. And then he needs to extend his MPLS to this other router. So for that he needs a TLOC extension interface. And then since we have sub interfaces, we need a parent interface as well. That's all. I think we don't need any routing protocols. Obviously we are using static routing. And yes, let's add VPN 10 first. VPN 10 move Next. And we know that for VPN 10 we need this VPN 10 LAN interface and also a OSPF template. Let's add that. Let's add VPN 20 as well. There we need only a VRRP template. Let's go ahead and check this. Add, go down, we don't need anything in cellular. Banner, let's use the existing template. Policy, let's use the same policy which we have already created. That's it. Let's create this. Now, even before the router comes up, since this is a virtual router, what I'm going to do is I'm going to attach and just attach any one of the available serial numbers. Maybe this. Now we have to fill up the values. Edit template. Yes. So what's the VPN 20 LAN interface? Gigabit 6 is the VPN 20 LAN interface in this router as well. Description VPN 20 and his IP is .3 and this guy's priority is going to be 110 because he's DC router 1. 20.1 is the VRRP IP and VPN 10 LAN interface is gigabit 5. VPN 10 LAN IP address is, I think it's 10.11.2.1 and then router ID for the OSPF, I'm going to keep it as the interface IP and I'm going to enable OSPF on gigabit 5. Interface cost, I'm going to keep it 20 and as we already discussed, we need two default routes. One pointing to the directly connected next hop, which is MPLS in this case, which is 210.1.1. The second one is the TLOC extended next hop. That's 201.11.10.1, I think so. VPN 10 parent interface is gigabit 3. This guy also has sub interfaces, right? So we need to create parent interface and he is also going to extend his MPLS TLOC to router 2. So he is going to extend it via gigabit 3.100. Description VPN 0 MPLS TLOC extension and the IP which we have planned for 3.100 is it's 10.10.10.1/24 and he is going to extend gigabit 1. That's the MPLS interface in router 1. And who's the internet interface in this case? Internet interface is going to be 3.200. So router 1 believes that he have a direct connection to the internet transport via 3.200 and VPN 0 internet interface and the IP address we planned for that is 201.11. I think it's 10.2/24 and then MPLS is obviously gigabit 1. Description, let it be MPLS interface and the IP which we have planned is 210.1.2/24. That's the local IP. Host name for this router is DCRT1. Location same. System IP, this is 1.1 as we planned. Site ID 100. Let's update. Let's download this for a safer side and click next. And if you see here, we will not see any config diff because obviously the router still haven't came up in the overlay. You see only the local configuration from vmanage is available. Let's push this. The vmanage will tell in a bit that the router is offline and we'll push the configuration when the router comes online. You see, it's done, scheduled. And if I go under configuration devices, and this particular second line item, if I go to this side, he's sync bending and the device is offline, so he's waiting for the device to come up. Let's bring up that router. First, let's start with the basic configuration preparation, and I have already created a template. So it's 101, isn't it? And same as we done for router 2, but there will be a little difference. I'll show you. This is same, and the next stop in this case is going to be 201.11.10.1. We are going to use the TLOC extension interface to bring up this router, because as I told you, internet is the only path where controllers are available. 192.168.0.52, and you see we are going to use gigabit 3.200 on this router. So for that I also have given the parent interface in the CLI mode, and the IP for this router is .2. Yes, standard interface. I think everything else is good. We are ready with this, and if you remember, we have reloaded the router a bit ago. Let's go back to the router and see his status. DC router 1. Okay, there he is. Let's get into the router. Yes, now he should be in controller mode. Let's quickly validate and move forward. Show version pipe include mode. Yeah, you see he's in controller mode, right? And also you should be able to do show SDWAN related commands. Now first step, let's install the root certificate which we have in the boot flash. This root certificate I have copied before starting this lab. Root. You see it's there. I'm going to install that first. Request platform software root search software SDWAN root search chain install boot flash. This is the one. The root search chain is installed. We can quickly validate that by show SDWAN certificate root search chain pipe include. No, it's a typo. It should be network. Yes, there it is. Let's copy the basic configuration which we have created. Go ahead, config transaction. Okay, commit. There is some issues. Interface 3.100 IP address value 201.11.10.2 configuring IP routing in the sub interfaces. Okay, I hope you would have understood the issue by now. I think it's the encapsulation command which I'm using. Let's get back into the interface gigabit 3.200. I think I'm missing this particular thing, not sure. Interface gigabit 3.200 encapsulation .1Q200. Let's commit now. There is again some issues. Hold on. So let's get into interface gigabit 3. I hope I should do MTU 1504. Let's commit. Have we taken the config? Yes, it does. So let me get back to this configuration file. I'll show you what are the things I changed. I have added this command extra, which is mtu1504, and also I missed one important basic command, encapsulation .1q 200 here. Okay, I have saved the file. I'll see if I can share these files in the description box, but I suggest you to do it on your own, but it will be there in the description box in case if you need that. Okay, let's go back here. Now, what do you think? The router should start forming the control connections? If your answer is no, you're right. It should not start form control connection because he still don't have a certificate, right? And also he doesn't have a serial number. So show SDWAN certificate serial. If you see, he doesn't have a serial number, and this chassis number is just a temporary chassis number. What should we do? We should go to the vmanage and generate a OTP and share it to him. Let's get to the vmanage. The second line item, this is where the template is currently attached. So we'll use that one to generate the OTP. Generate bootstrap. Okay. If we go down, this is the UUID. Let me copy that, and you remember the command request platform software SDWAN vEdge cloud activate chassis number is this, and then the token is gonna be this one. Okay, we have accepted this. So now we expect this router to establish control connections. Let's quickly do this. If he is able to ping 192.168.0.52, he's not able to ping. Not sure why. Let's see. I think there is some issue in the underlay. Let's first ping the next stop. Yes, I'm able to ping the next stop. Do I have a show IP route? 201.11.10.1. Yes, I have a static route pointing to that. Okay, you know what? I know the issue. Let me tell you what is the issue. This subnet, the 201.11.10.0/24 subnet, is available between router 1 and router 2. Now think about the internet router's perspective, right? He doesn't know that subnet at all. I actually haven't created a route pointing back to DC router 2. So the inet1 cloud should point back a route for this /24 with the next stop as DC router 2, so that any traffic destined to this IP should be sent via the data center router 2. Let's do that. Get into inet1. Show IP interface brief. Load unassigned. And yeah, the first one. So IP route 201.11.10.0.255.255.255.0. The next stop is 2. Let's see whether this fixes this issue. Let's go back here. Yeah, you see, the moment I added that route, he is able to authenticate with the vManage successfully. There is one more general practice which is always followed in this kind of design is instead of having a public IP for that TLOC extension link, we could have add a private IP and then enabled NAT on the gigabit 2 interface, which is the internet TLOC interface on router 2, right? So that when the traffic goes out of that router, it will get NATed. So you don't need to add a static route, and also you don't need to buy a extra public IP, right? That's a preferred method, but since this is my lab, I have my own choice, right? So I used extra public IPs, but just know that that option is also available. Let's quickly, so as I told you already, we'll wait for the OMP's logs, and let's quickly check control connections if we can see something already. Yeah, it's trying to connect. Let's give it some time. We should see the OMP logs coming up, and we expect this router to go ahead and fetch the template automatically from the vManage. Let's see. I am in the network page of the vManage. If you see, the router is currently unreachable. So as I told you, the router first comes up and then goes down. So we should give it some time. It should come back up again. You see, it's almost reachable. That's a success. You should see it reachable and then unreachable, and then it should come back up as reachable. After that, it will not go down. So you should see it unreachable only one time during the onboarding process. If it stays in unreachable, then there is a big issue. I mean, the router haven't onboarded properly. So you have to check it further. Let's see from router's perspective now. Yep, you see, OMP peer came up. Let's quickly do SD-WAN control connections. You see, there is some init backup VRRP messages. How did this router know about the VRRP configuration? So that's an indication that he picked the configuration from the template already. Let's see. Let's give it a minute. I have given the router ample amount of time, so let's check show SD-WAN control connections. Actually, it should have been connections. Yep, control connections are fine, and then let's check the show SD-WAN OMP peers. My bad. Peers. Here we go. OMP is up as well. Now, if I do a show IP interface brief, you see I have received configuration about everything. The MPLS interface, the internet interface, and also I should have received configurations for the LAN interfaces. And if I do show VRRP, show IP VRRP, I think that's the command. Show VRRP. Yep, show VRRP brief. You see, I have received almost all the configurations. The OSPF configuration should also be there, but remember, we haven't configured the core switch yet, so we don't expect it to come up, but at least the configuration is ready. Let's get to the vManage, and you see this router is up, and if I go to the templates, now you see DC router 1 came up, and also he consumed this template successfully. That concludes the onboarding of both SD-WAN routers in the data center. We have brought them up successfully. Let's move forward and quickly configure the LAN side as well. Here in the DC switch, we'll start configuring the interfaces connecting to the VPN 10 first. Let's go ahead and Ethernet 2/1 IP address 10.1.1.2.255. I think it's /24 here, and then no shutdown. Let's go ahead and do the same for 2/2. That's connect to the second router. IP address 2.2. No shutdown. And let's just ping the next stops and validate this first. Yes. No. You know what? I just validated the data and identified that, say, in DC router 1, it should have been 10.1.1 subnet, and on the second link connecting to VPN 20, it should have been 10.1.22. Instead, I swapped the LAN interface IPs between DC router 1 and DC router 2 from my initial plan. So I should change this back so that this router should be able to ping. That's why it's not able to ping currently. Let me correct this IP issue first. Okay, I have corrected the configuration. Let's get back into the DC switch and then check this ping again. Okay, I'm able to ping now. Same way, let's ping the second router, host 2.1. Yes, I'm able to ping that as well. Okay, let's go ahead and configure the DC server connecting interface, which is interface Ethernet 2/11, and I is going to be a switch port mode access, switch port access VLAN 10, and I think I haven't configured VLANs yet. Name VLAN 10, VLAN 20. Let's just give the name as VLAN 20. I'm not able to think of a better name, so let's keep it simple. And then we are going to create a SVI here for VLAN 10. The VLAN 10 gateway will be the core switch, and then from the core switch there will be OSPF running, which will carry the traffic up to the DC router 1 and 2. So let's configure this. The IP is 10.1.10.1/24. No shutdown. Now let's get into the DC server and then we'll validate whether we are able to ping up to this gateway first. Here I am in the DC server. Let's ping the gateway 10.1.10.1. Okay, what happened? Yes, Ethernet 2/11, no shut. I'm not able to ping the gateway. Let me just quickly check this. Okay, the VLAN 10 interface is down. I think I haven't issued a no shutdown. No shut. Yes, here you go. I'm able to ping to the gateway. Let's just clear the OSPF now between this core switch and the edge routers, DC SDWAN edge routers. Maybe let's put OSPF process as 10. Process ID doesn't matter really. And then I'm not going to give any router. Let's give a router ID. Why not? Let's give same thing. And then auto cost reference bandwidth. If you remember, I have set the reference bandwidth as 10,000 Mbps there, so I should match it here as well. And then followed by that, what we are going to do is, if you see here from this DC switch, we are able to ping 100.100.100.100. That's a internet destination which I have created in the internet servers router, which I have showed you earlier in the GNS3. So I'm able to ping that. To reach this, I have actually created a default route here. If you see, there is a default route what I'm gonna do, I'm gonna get back into this OSPF and then default information originate. I'm not gonna give always. Since we have a default route, it should be enough. It will take that default route and get it advertised. Then we'll get into the Ethernet 2/1 IP OSPF router, no, IP router OSPF process 10, and it's gonna be in area 0. And also IP OSPF network is gonna be point to point, if you remember from our earlier configuration in the SD-WAN edge routers. And also we have to do IP OSPF cost for this link. This is the primary link connecting to the router 1, so I'm going to give it a cost of 10. Let's get into the Ethernet 2/2. This is a secondary link connecting to second router. Let's do the same thing. IP router OSPF 10 and area is 0. IP OSPF network point to point, and IP OSPF cost, I think I have given it 20. Let's see if the OSPF came up here. IP OSPF interface brief. Yes, OSPF is enabled. Yes, neighbor is also there. Show OSPF neighbors. You see, both neighbors are full. Let's go to DC router 1, and then here in DC router 1, if I get in admin and the new password, yes, show IP OSPF neighbors. You see, there is one neighbor. And then if I do a show IP route VRF, show IP route VRF 10, that's VPN 10. You see, I have already received the OSPF route, which is the default route originated by the DC switch. Same thing let's do in DC router 2. Admin at 123. Enable show IP route VRF 10. Yes, I have that. Obviously the neighborship should also be there. Yes, neighborship is also there. So from the core switch we are receiving the default route, and if you remember, while creating the templates we have created policy so that hold on, I will show you. Assurance section router OSPF. Yes, we have created template so that OMP is redistributed into OSPF, but we haven't created policy so that OSPF will be redistributed into OMP. That we haven't done. Let's complete that here itself. Let's go to config templates and let's go into the OMP template, or we'll go into VPN 10. And here in advertise OMP, what we are gonna advertise into OMP from VPN 10 is, let's click new advertise OMP. Yep, here it is. I'm gonna take OSPF and get it advertised. Let's add. Remember, this template is going to get attached to the branch also where we don't have OSPF at all, but that will not have any effect. In case if you are doing this in production, it's advisable to have a separate template. Update. And when we do changes in the feature template, it will be reflected to all the device templates to which the feature template is attached. So let's click next. Let's see what's the config getting changed. We should see that OSPF is redistributed into OMP. That's the missing piece, right? Let's see the config diff. Click config diff, side by side diff. Let's see where is the change. Okay, here is the change. If you see under OMP section, we are advertising the OSPF external but specific to VRF10. Okay, let's push this configuration. So the configuration is getting pushed to both routers. Let's just give it a minute. Okay, here you go. Config is changed in both the routers. So whatever it's receiving in OSPF, it is going to redistribute back into OMP as well. So we have achieved mutual redistribution in DC router 1 and DC router 2. If we bring up any other branches with VPN 10, this default route should be advertised now. We'll see that when we bring up branch 2 and branch 1. For now, let's move forward and do the VPN 20 related configurations in DC switch. For VPN 20, DC switch is going to just act as a transparent L2 switch, right? For that, I need to configure interface Ethernet 2/12 and Ethernet 2/3, Ethernet 2/4. All these interfaces. 2/12 is connecting to voice phone, 2/3 is connecting to DC router 1 and 2/4 to DC router 2. Everyone will be switch port mode access, and that switch port access 20, switch port access VLAN 20, no shut, and let's quickly do this. Show VLAN. Yes, VLAN 20 is allowed in all these three interfaces. And let's open DC phone. Now let's get into the DC phone and see whether he got a IP from DHCP. He haven't got any IP yet. You know what? We haven't configured DHCP on the router itself. And then even if I do show run DHCP, yep, we don't see any DHCP config at all. Let's click on DC router 1, edit, and then let's go under VPN 20. Let's click edit. And we'll add a sub template for this interface, which is going to be a DHCP template. Save, update. Now it's going to prompt us to fill up the DHCP values. Let me click edit. And here it's 10.1.20/24, 10.1.21. That's the gateway. Let's update. Next, let's configure. Let's wait for this to get pushed. Okay, the config is pushed. Let's get back to DC phone. If you see, he got an IP from the DHCP server running in DC router 1. I'll leave the DHCP server only on the router 1. If you know, I have assigned a /24 already there in the DHCP lease. It's not advisable to have two DHCP servers servicing the same LAN. It will create clash. So we'll keep it simple by having it only on the router 1. Let me quickly check this. Yep, it got assigned .4. What I will do now is I will just quickly validate 20.1 reachability, and also will validate 20.2, that is router 1. Here you go, and 20.3, that's router 2. Yep, we are able to ping everything. Let me get into DC router 1. If you see DC router 1, I have logged into that from the vManage CLI. From here, if I do show VRRP, this is for gigabit 6, which is VPN 20 interface. He is the master. Same way, if I get into second router from here, show VRRP, he is the backup router, right? That concludes our VPN 20 configuration for data center. We have completely brought up the data center now. I don't see any configurations pending for the data center side. We'll go ahead and configure the rest of the sites now. Now let's start with branch 2. We'll bring up the SD-WAN router as well as the LAN components. In branch 2, the router model is Cat 8 kV, similar to our data center. So there is no need for us to recreate most of the templates which we already created. First, system template, there is an existing one, AAA existing, BFD is already available, security available, OMP available, banner available, policy available, VPN 0, MPLS interface, internet. So I keep going. Yep, almost everything is already available, right? We are going to reuse those feature templates to build our device template for BR2 RT1 router. Let's keep going here. Now to bring up this branch 2 router, we don't really need to create any new feature templates. We'll try to reuse whatever we created for the data center. Let's click here, and then the model of router will be Cat 8 kV there in branch 2, and it's an edge. Template name, I'm going to keep a common template name, say a site with one MPLS, one internet. Let me name this like this, and also let me name it as one router, one MPLS and one internet, VPN 10 and 20. If you see, I'm giving a descriptive name based on the design of the site, so that if there is another site coming up in the same design as our branch 2, we can simply reuse this template which we have created. We'll attach that router as well to the same template. Let's move on. System, let me call the system template which we already created. AAA, we created already. BFD, same BFD. OMP, let us select the OMP which we created, and security, this is the one which we created. Now for the transport VPN, if you see branch 2, we need VPN 0 with one MPLS, and then we need one internet link template. Apart from that, we don't need a parent interface or a TLOC interface template there. We don't really have a sub interface, or we are not going to do TLOC extension also. So we don't need them. We can quickly move forward. There we need both VPNs. So to start off, let's select VPN 10, move it, next. In this site, we are just going to have a LAN interface in VPN 10, and the user machine there is directly connected, so we don't need any protocols or DHCP anything. Let's add again VPN 20 now, and next interface. Now VPN 20, we'll select the normal VPN 20 interface without VRRP. That should be enough since we have only one router, and then we need a DHCP there. Let's select DHCP, and if we keep going, we'll select banner, and we'll use the policy which we already created. I think that's it. Let's create this template. Now if you see here, the template is ready. I'm going to attach this to any one CSR device which we already have. Let me select the first one, attach, edit. Yes, VPN 20 LAN interface is going to be gigabit 6 there. Description will have the same description. IP address, the one we planned there is, it's I think it's 20.10.3.20. That's the IP which we have planned, and we are going to use the complete pool there as well. And then default gateway is going to be this one, obviously. VPN 10 LAN interface is gigabit 5 description, and the LAN interface IP will be 10.3.10. Going down further, on the WAN side we are going to have two default routes, one pointing to 210.3.1, that's the MPLS next hop. Another one is 201.11.3.1, that's the internet next hop. And VPN 0 internet interface name here is gigabit 2. Description IP address is this one. And for MPLS it's gigabit 1, and description IP will be similar to this, 210.3.2/24. And then moving on, the host name for this device is BR2 or T1. Location is, let's keep the same thing. Yes, the plan I think which I have is 103. Site ID 300, and we will enable port hopping. This is a branch, so we'll enable port hopping, whereas we'll not do that for the hub sites. Okay, let's click next. Let me go back a minute. Let me just download this for a safer side. Let's click next. Let's push this configuration. So it should say that once the device comes up, I will push the config. Let's see. Okay, here you go. It's done, scheduled. Let's start to bring up this branch now. Let me get into this branch router. If you see, we already have enabled controller mode in this box, and this box is available in controller mode, isn't it? Yes, it is. And also I already copied the root certificate to this box. So let's start creating the basic configuration file now. Here you go, the basic configuration template which I have created for branch 2 router. Host name, username, clock, and system IP. I think I have given 103 when I'm filling the template, isn't it? We'll go back and change that. I have planned it to be 104. We'll change it in a minute. And site ID also should be changed to be 1002. We'll change it. And lab. And the next stop, we are going to bring this up via internet. So I'll give the internet next stop, and the vBond will be 192.168.0.52 is the vBond in our network, and the local interface IP is .2. Yes, apart from that, everything looks good. Before I paste this config, let me go to the GUI and get back to the template and change the system IP and site ID as per our plan. Sorry, I should go to change values, change device values. Next, edit. Let's go down. Okay, it should be 104 and 1002. That was my plan. So we'll just stick to the initial plan which I prepared. So that's why I'm changing this. Okay, that should be good. So we'll go back. Yes, the config is ready. Let me copy this config, get into the router, config transaction, paste the config which I have prepared. Let's just quickly validate whether all the configs have been taken successfully. Yes, it is. Let me end and save this. The next step should be installing the root certificate which we have, right? We still haven't done that. Before I do, let me quickly show you. Show SDWAN certificate. Root certificate might include. If we search for our root certificate, we should not see that. So, and also if you see show SDWAN control local properties, we see here it doesn't have the certificate installed yet. Obviously it still haven't got the root certificate itself, the enterprise root certificate. What we are going to do now is we are going to install the root certificate which we have. Request platform software SDWAN root certificate chain install it from the boot flash, and this is the file. Here we go. The root cert chain is installed successfully. Now for the CH device to get onboarded into the overlay, he still needs a OTP so that he can reach out to the vManage and get a serial number and certificate itself. So let's do that. Let's go to the vManage, configure device. This is the value to which we have attached the template, so we'll generate the bootstrap there. Let's click OK. This is the chassis number. Let's copy that first. Go to the CLI, request platform software SDWAN VH cloud, activate chassis number, the chassis number which I just copied, and the token which is the OTP. Let me copy that as well. Enter. We actually haven't validated a ping to the vBond. Maybe we can do that, or we should see some log which will indicate us that he is able to reach in first place. Yes, he is able to ping. That should be fine. Let's just give it a minute. Let's see if he's coming up. Yes, you see, he's trying to authenticate to the vManage, which is a good sign. As I told you already, we should see the OMP coming up. That's the indication the process have been completed. Also, let's see if from the network perspective, yeah, in the network page, here you go. You see branch router 2 already up and reachable. We may see it going down, but it should come back up eventually. Let's just give this some time. I'll hold and see. Okay, here we go. If you see this router, I can notice OMP is up. So I'm seeing anyway OMP up, and let's check the control connections first. Yes, all control connections are intact as we expect it to be. Let's check the OMP peers. OMP is up as well. From vManage perspective, I'm seeing branch 2 router 1 is up. Now if you notice, there is BFDs up as well. We'll come back to that in a minute. Let's just quickly check whether the template have been successfully attached to this box now. See, there is one device attached to this template, which is our branch 2 router 1. If I go back to this, earlier when we brought up our data center, we only validated the control connection. That is because obviously we haven't brought up any other sites that time. He's the first site to come up. Now since we have another site, we should see the IPsec tunnel, the data plane tunnel should be up as well. Let's check that. Show SDWAN BFD. sessions. Okay, here from branch to router's perspective, he have 4 tunnels. So first he have 2 tunnels to data center router 1 via MPLS and also via internet. Both are up. Whereas when he wants to establish data plane tunnel to the DC router 2, he is able to establish only via public circuit, but the MPLS is down. You know what? I think I know the reason. Let me show you why. If I ping this destination sourced from my MPLS interface, obviously I'm not able to ping. This is because if you remember, when we brought up the TLOC extension interface of internet circuit, right, between the data center router 1 and router 2, we added a static route in the internet cloud. Same way we should have added a static route for the MPLS TLOC subnet in the MPLS cloud, which we haven't done. So let's go to the MPLS router and add this. So we should see this coming up once we add that. So if I show you, this is the interface connecting to the data center router 1. So I should add a route 10 10 10 0. I think that's the subnet. Let me validate 1 second. Yeah, I just checked, that's the one. So it's actually 255.255.255.0 and it should point to this. Let's see now. Now here in this branch 2, let's quickly check whether the BFD session came up or not. Yes, you see, we have that tunnel up now. So it's up for last one. That's it. We do have the tunnels also formed successfully. That is the data plane tunnel. I think we are good between these 2 sites. We'll quickly validate the LAN part of branch router 2, which is these 2 interfaces, right? This is VPN 10 and this is VPN 20. Let me bring up the VPN 10 and VPN 20 host. First, to start off, I am in the branch 2 phone. If you see here, it actually got an IP. So the moment router got the template assigned from the vManage, he would have given the DHCP related configuration along with the template, right? So this phone also got a IP. Let me quickly ping. Also, let's quickly check the route table. He should have got a default route as well. Yes, he did. Let's ping the gateway. Yes, I'm able to ping. Let's quickly ping 1023. I think it's 10 120 100. If I remember right, I think it took 4. Yes. Let me show you who's 10124 if you forgot. That's the data center phone. 10124. Okay, we are good with the voice phone over there in branch 2. Let's quickly get into the user machine. Here we go. This is the branch 2 PC. Let me first ping 10.3.10.1. Who's the gateway? Yes, I'm able to ping. Now let's ping 10.1.10.100. That's our data center server. You see, we are able to ping. But if I ping 10.1.24, which is the voice phone, I'm not able to ping. This is because this is not in the same VPN as the voice subnet, right? So we will not be able to ping between the data and voice. Let me show you 10.1.10.100. You see, first hop is our local gateway, and then we are reaching up to 10.10.10.2. That is the TLOC IP, I think, TLOC extension MPLS interface. And then eventually we are reaching to the LAN interface. I think we are landing in the data center router 2. So we haven't done any specific policy, so that's why it's choosing based on the default mechanisms, and it's reaching up to data center router 2. Finally, it reached up to the actual server in the data center. That concludes our branch 2 bring up. We have validated both VPN 10 and VPN 20 from branch 2 all the way up to the data center. Let's start bringing up the other site now. Let us start to bring up the SD-WAN routers in branch 1 and follow that up by configuring all the LAN components as well. In branch 1, we do have a VH cloud router, so we will have to create a complete set of separate templates for the same. In vManage, there is always separate templates created for CH and VH. Let's discuss about the feature templates that we have to create for BR1 RT1 router. As we done for the data center routers, we need to create a new system template. Why a new system template? Because this is completely separate. This is for VH router. And then a AAA, BFD, security, and OMP. Okay, one more thing. Even though it's a separate template and it's for VH, the parameters and concept remain same. Okay, it's just that we have to maintain two separate templates for VH and CH. And then follow that up with banner and localized policy with the TPI flow existing. This is the catch. This localized policy is not a template, it's a separate policy. So we can reuse the same policy which we have created for CH. There is no segregation there in policies, whether it is for CH or VH. Follow that up with VPN 0 and MPLS interface template, internet interface, VPN 10, LAN interface for VPN 10, VPN 20, and a LAN interface for VPN 20, DHCP. So in this case, except for the localized policy, we are going to create everything newly. Let's start. Okay, here I am in the branch 1 router 1. Let me bring up the basic configuration file. If you notice the difference, this router is VH Cloud. It does run the Viptala OS. So the basic configuration, the CLI configuration will look different. This will be very equivalent to what we have done with the vManage, vBond and vSmart. Whereas for Cisco iOS XC SD-WAN routers, the configurations will be different. Let's start with the host name, which is branch1 RT1. Location. And I have already planned the system IP and site ID. Let it be org name. Clock and vBond data, and the vBond IP is 192.168.0.52. We are going to use the internet interface to bring up, and IP address is 201.11.2.2. I think so. Let me quickly validate this once. Yep, that's right. And all other seems fine. And the next stop is .1. Let me copy and get into this router. That's config T here. It's not config transaction in this router. Commit and quit. If you try commit and quit option, I mean the commit and quit command in Cisco iOS XE SD-WAN routers, it will not work. Only commit will work there. You see, it took the config. As we done for the other routers, the next step is to install the enterprise root CA. Actually, I still haven't copied the enterprise root CA file to this router. I'm just going to pause this. I'll copy that file here and then we'll connect back. Okay, I just completed copying the file. Let me show you. You see, I just copied the file over here. Now let's go ahead and install this root certificate. Request root cert chain install home admin. Yes, let's install this. Yes, it's successfully installed. So we have installed the root cert chain and also we have done the basic configuration already. The next step is generate a OTP from vManage and share it with this router so that he can get the serial number and certificate from the vManage. Followed by that, he will go ahead and establish a permanent TTLS tunnel with the controllers. Let's start this. Here in the vManage, let's go to configuration devices, and this time it's for a VH cloud, not for a Cat 8 KV. So let me pick one and generate bootstrap configuration there. Okay, and we'll copy this UUID request. Before that, let's quickly ping 192.168.0.52. Yes, I'm able to reach. Now go ahead and request an VH cloud activate chassis number and token is this. Go ahead and paste the token. Let's give enter. Let's give it some time and wait for this to come up. Here you go. It's trying. If you see, it just initiated the connection with the vBond and vManage. We don't expect to see vSmart now. This is the initial OTP based authentication. So once this is done and he get a certificate and serial number, later he will establish permanent connection with vBond, vManage and the vSmart. Let's quickly go ahead and do show control local properties. Here you go. The certificate is already installed, and if I do a show certificate serial, yes, I see a serial number as well, so he should come up properly. Let's validate. Yes, there is no control connections yet, so the initial control connections have been turned down, so they should come up now. If we get to the vManage monitor network, now here you see branch router 1 is also there and he is reachable as well. Let's get back to the CLI and do the control connection again. Yes, the control connections are successfully established. Let's check OMP/PS. Yes, there is a OMP session with the vSmart as well. Let us also quickly check BFD sessions. If you see here, we have BFD sessions with 11104, 11104, 101, 102 and 104. He have BFD sessions with everyone via public internet. There is no connection via MPLS because still we haven't configured the MPLS interface at all. We haven't created a template yet for this box, right? Once we do that and push the template, it should come up properly. So let us keep this here. Let's go ahead and create the templates and come back and validate these things. Under configuration templates, now the challenge here is this is a VH box, so we have to go ahead and create a new set of feature templates totally for this one. So whatever we have created cannot be used for a VH. We have to start all over again. Since I have already explained you the facts of most of the templates which we have created, we are going to anyway create similar templates for VH Cloud. All the options is going to be similar as well. I'll suggest you to watch this if you think it will help you, or you can even skip them. It's very similar to whatever we have done already. Okay, we have the template now. Let's go ahead and attach this. Attach it to BR1 RT1. Attach. Now we must fill all the values. VPN 20 LAN is G0/3. The interface numbers of a VH router will look different. If I go to this VH router and do a show interface tab, you see the numberings will be like this: GE00, GE01. That is how we have to fill as well. So GE03 is VPN 20. Let's have the same description. IP address in this site is 10.2.21/24, and VPN 10 LAN interface is 2. Let's have the same description. IP will be 10.1 as per my plan, and we are going to have two default routes in the VPN 0 transport VPN. One pointing to 210.2.1, that's the MPLS next stop, and another one will be towards the internet next stop in this site. Now VPN 0 interface, internet interface is GE0/1. Description: VPN 0 internet interface. IP address is this one, 2/24. Let's talk MPLS now. MPLS IP is 2/24, and his interface is 00. Description, let's keep it simple. Host name, we have planned it to be BR1 RT1. Location, let's have it as Chennai. System IP 10.1. Did we change for branch 2? I think we did. Yeah, so we can go ahead with 103. Site ID 1002. Hold on a minute, let me just quickly validate what we did for branch 2. Okay, branch 2 is 1002, and we should keep this as 1001 as per our plan. Let's go ahead, 1001. Update. I'm just going to download this for safer side. It's template 7. Let's click next. Let's click this. Fail to create a preview, fail to fetch configuration for device. Is the device still on or down? Yes, I'm not sure what's the reason. Let's push this. It's a failure. What it is saying? Invalid value for console baud rate. Okay, let's go ahead. Template console baud rate will be there in system. System edit. Okay, did I miss to choose this? Let's keep it to be 115200. That's the default for VH if I remember right. Okay, let's try pushing again. Okay. Yep, now you see this is the use of downloading the files always. Yes, next. Let's see now. Yes, that's good. Okay, let's push now. It should take it. Let's see. So failure again. Let's see what's the issue now. Device failed. There's a error path. Okay. I hope I have told you about this in this video earlier. Some of the devices may need VPN 512 template, even though we are not using that, right? So that's the error. Here we need to create a VPN 512 template just as a dummy so that it doesn't complain. If we don't do that, right, it looks like we are going to remove VPN 512 altogether from that router, which it doesn't allow. That's the reason it's complaining. What we can do here is, let me do this. Let's take this VPN 10 from our VH Cloud, copy this 512, copy, and let me also copy this LAN interface, copy 512. Now let me search for VPN 512, and first here let's edit this. This is VPN 512 and it's OOB. And I don't see anything else needed. Let's just update and search again for VPN 512. This time this LAN interface of VPN 512. What I'm going to do is I'm going to keep that simple. In VH Cloud I know it's Ethernet 0, so what I'm gonna do here is I'm gonna keep it shut down, and I know the interface already. It's ETH0. I don't need any description. Leave it to be default. No IP. Nothing else. Just save this. Under devices, for this VH template, edit, go here to VPN 512, select this one and add an interface, and it will be this. Now update, attach the device again. Let's see if we are going to get one more error. I hope no. Let's see. Let's go to config. Yep, there is. Let's configure. Okay, there you go. It's a success. Let's get back to the router. Let me restart. Okay, I think I should allow SSH, which is getting blocked. Let me do that quickly. I'm actually doing an SSH to the internet interface of the router. That's how I'm accessing it. Since I pushed the template without allowing SSH access, it just thrown me away. I'm gonna allow this now. Okay, config pushed. Let's try again. Yep, there you go. info interface tab. Yes, there is the WAN interface, and then the LAN interface configurations are all there. Let's quickly do the validations. Control connections, we have already checked this. OEMP is there as well. Let's see the BFD sessions now. There you go. We see a lot of BFD sessions. Let's just check this one by one. We have BFD session to 101 DC router 1, DC router 2, and the branch router. I can see that via MPLS the tunnels are not coming up. Let's quickly validate this. Let me try ping. Okay, I'm not able to ping this. Let me check the next stop first. Ping. Okay, I'm not even able to reach my next stop. Let me check my lab topology. Maybe I haven't brought up the link. Let me check this and come back. Okay, I just identified the issue. It's a VLAN issue in my lab topology inside my lab. So I just sorted that post, which I'm able to ping to the next stop. Now let's check the BFD sessions. I hope it should have came up. Yes, they are up now. So this is as expected. So I'm having two tunnels to the router one via MPLS and one via internet. Same for router 2 in DC and also for the branch 3. I'm really not sure what is this about. I'm not sure why there is one more entry which shouldn't be there. Maybe this is, you see here, it's on a different port, right? It's an old stale entry which is not cleared. I'll check what I need to do to clear this stale entry, but that's a stale entry. These are the 6 entries which we need to focus and which we expect to be there, which are there. So we are good for now. We'll move ahead and check the host machines behind branch router 1 and we'll validate the DC and branch 2 reachability from them. First, here I am in the voice phone of branch 1. Okay, it's expecting a DHCP IP, but if you remember, we haven't created a DHCP template at all for VH devices, and we haven't called it in the VH template which we created. Maybe just to save time, I'll just go ahead and assign a manual IP here. Anyway, I have shown you the DHCP setting in 2 sites already, in data center and in the branch 2. The IP should be 10 to 20. Let's keep it as 100, or let's keep it as, okay, let it be 100. Why not? 250, no shut. And the gateway is going to be I must check this as well. Let me check my VLAN assignment. I hope same issue as I did for that interface. There is a VLAN mismatch in my underlay, in my lab underlay. Let me quickly check that. Okay, here you go. It's pinging now. It's again a VLAN issue in my backend. So I just resolve that. We are able to ping the gateway from BR1 phone. Let's just try pinging 10.1.20.4. Yes, that's the data center voice phone. Let me do this as well. Yep. To the gateway 10.10.2, that's the MPLS interface, if I remember right, in DC. That's the TLOC extended MPLS, and then to the destination. Also, let us ping 10.1, I think 10.3.24. I'm not sure what IP it have took. Let me check the IP address of BR2 phone. BR2 phone, what's the IP he have taken via DHCP? 10322. 10322. Here you go. I'm able to ping the other site as well. The point here is when I try to reach BR2 from BR1, it goes directly 210.3, that's BR2. So I'm going directly to BR2. Let's get into the user machine here in branch 1 now. Okay, here I am in BR1 user machine. Let's first ping gateway 10.2.10.1. Yes, I'm able to ping the gateway. Let's ping 10.1.10.100. That's the DC. And let's also ping 10.3.10.100. That's the BR2 user machine. Let's do a trace to 10.1.10.100 first. Yes, it's going to 10.2.10.1 and then it's going to 201.11.1. That's DC obviously, and then let's trace 10.3.10.100. That's BR2. It should go directly. That's the expectation. Yes, it's going directly. Okay, that concludes branch 1 bring up. We are able to successfully establish control connection, OMP peering is up, and also we validated that IPsec data plane tunnels are up from this router all the way up to data center router 1, router 2, and also as well as branch 2 router. In this section, we are going to discuss about the types of policies in Cisco SD-WAN. Let's start. To start off, we do have two separate policies. One is control and one is data. I hope you would have understood by the name. The control policy will affect the control plane, whereas the data policy is going to affect the data plane. Now, within the control policy, we do have centralized and localized policy. Centralized policy is nothing but when you write this policy and implement, it's going to affect the complete overlay, right? Whereas localized policy is just going to affect a particular router to which it is pushed to. Moving on the data policy, there is again two segregations, centralized and localized. So when you have a centralized data policy, that's going to be implemented throughout the overlay wherever you have selected it to be, and then it's going to be executed in the data plane, right? And the localized data policy is going to be implemented in a specific router where it is called to be. The examples of centralized control policy are, say example, we can create a policy where we can alter the topology of the networks. Say VPN 1 is hub and spoke, VPN 2 is full mesh, VPN 3 is partial mesh. We can achieve everything using a centralized control policy. The examples of centralized data policy will be app aware routing, traffic data, or CFLOD. So when you take app aware routing, it's nothing but a policy written in a router, right? Which states that when you see a bad link, you move my critical application to the other link. For that, the router needs to look into the actual data. So that's a very good example of centralized data policy. And if you look at localized data policy, the best examples are access list which you bind on an interface or some QoS policy which you are going to create there, right? They all come under this category. And for localized control policy, think of a site with a WAN edge router and you have an ISP1 and you are tasked to create a BGP peering with the ISP. In that case, on that particular router, you need to create a BGP route map, right? That will come under localized control policy. I hope this would have given you some idea about the policy architecture in Cisco SD-WAN. Let's keep going and explore our lab topology and play around with these policies. Before we start applying any type of policies, let us explore the current traffic flow and design of 10 and 20 service VPN in our lab. By default, all the service VPNs is expected to be in full mesh. Let's see. I have logged into all the routers, DC router 1, DC router 2, the BR router 1, BR1 router 1 and BR2 router 1. Now let's start off with checking the control connections. We have validated this already, but anyway, we'll do it again one more time. From DC router 1 perspective, we are able to see the control connections good. Let's check in DC router 2. Yes, good there. BR1 is a VH, so that command will not work. Let's come back there. Here in BR2, yes, it's fine. In BR1 also it's fine. Show SDWAN OMPPS. Yes, up. Second router. Yes, up there. And also in BR2. Yes, it's up there as well. And in BR1. So if you see between VH and CH, the important difference is the SDWAN keyword. Mostly the other keywords will be always same. Let's go ahead. Now let's check the BFT tunnels. Show SDWAN BFT sessions. From DC router 1 perspective, he have a tunnel to 103, 2 tunnels to 103. We have 2 tunnels to 104 from router 2. Yes, I do have tunnels to the other 2 routers. Now in BR1, we have tunnels to both DC routers and as well as to the branch 2. Now from branch 2's perspective, we should have successful tunnels as well. Yes, all the tunnels are good. Now in the overlay, the tunnels are all fine. We have 2 service sites, VPN 10 and VPN 20. By default, any service VPN will be in full mesh, meaning we already checked that when we tried to ping from BR1 to BR2, the traffic went directly in both VPN 10 and VPN 20, isn't it? I'll show you how the routing table will look like. Show IP route VRF10 from DC router 1. If you see here, I'm trying to look for 10 to 10, which is BR1. I have to reach to 103 router, whereas if I want to reach this subnet, that's behind BR2 site. That's from the data center's perspective. Same way, if I go to, let me show you in BR2, the command will look similar there. Show VRF10, right? If you see, first for 10.110, that's the subnet from data center. This is also a subnet from data center. This is again a subnet from data center, isn't it? Yes, that's a subnet from data center. And this subnet 10 to 10, that's a subnet from 103. Who's 103? BR1. So when you want to reach to BR1, which is a 10 to 10 subnet, VPN 10 subnet, you go directly. So that's the current status. Okay. Same way, if I go to BR1, the output will look a little different in VH router, but anyway, it will show you the same thing. So from BR1 perspective, if you try to find BR2 route, you see this is the route 10.3.10. The next stop is 10.1.1.104. Okay, the 4 is in the second line. If you are able to read, this is the complete next stop 10.1.1.104. So BR1 is pointing back to BR2 for his subnet directly in VPN 10, as well as BR2 is pointing back to BR1 for VPN 10 subnets directly. So as I told you, and also we have already validated this, VPN 10 is in full mesh. If I do same thing for VPN 20, see for from BR2, VPN 20 subnet of BR1 is available directly, so he will reach to BR1 directly. And If you remember from our theory classes, I told you two types of routes, one service route and one more is TLOC routes. So whatever you're seeing now, this is service route, which is in that specific VRF. When I say VRF, it's the VPN. Now, the next stop for this subnet is informed to be 10.1.1.103. Now to reach to that router, what are the things we need? This is the system IP, right? We need the WAN interface IP and also the encryption key details, right? So where will we find that? We should find that in show SDWAN OMP tlogs, and let's give enter. So this is for 11104, which is actually, I think it's local. I'm trying to find for 103. It should be there somewhere. Let me go. Yeah, you see it's there. There it is for second router of data center, public internet TLOC. So we have the TLOC entry for every tunnel endpoints, right? The TLOC interfaces available. Here it is. 11.10.1.1.103 MPLS interface of this router. That's one. And if you see inside, we have the encryption parameters and also private port and also the public IP, private IP details, everything. And if in case you see public and private IP both same, that means that router interface is not behind a NAT. If in case that router interface is behind a NAT, then you will see the public IP separately and the actual private IP separately. Here it is. You see 10.1.103 for public internet TLOC as well. We do have that data. So the service routing table will recurse to the TLOC routing table. That's how the packet gets encrypted and sent out the actual interface so that it reaches to the other end and gets decrypted correctly. That's the current status of both VPN 10 and VPN 20. They are in full mesh. We will now configure centralized control policy in our overlay so that VPN 10 will be designed as a hub and spoke and VPN 20 will still remain to be in full mesh. Now our target is to make VPN 10 as hub and spoke and leave VPN 20 to be the full mesh. So even in production scenarios, we will see that mostly data traffic will be hub and spoke because most of the destinations the user is trying to reach will be towards the data center servers. But in case of voice, they may need side-to-side direct connectivity, right? So how do we achieve that? We will achieve that by tweaking the control plane. For that, we will be doing a centralized control policy. What happens in the backend? Say we have subnet A in branch 1 VPN 10 and subnet B in branch 2 VPN 10, and say for example in data center we have maybe subnet C in data center. Okay, what happens is, if you know this Cisco SD-WAN architecture already, every route advertisement happens via vSmart. The routers doesn't exchange control plane information directly. They all send it to the vSmart, and then vSmart will distribute the route to the other sites. So in this case as well, data center will send about C to vSmart, and BR1 will send about A, and BR2 will send about B to vSmart. What we are going to do is, we are going to write some policy here such that when vSmart advertises to branch 1 about the subnet B, he will change the next stop to be data center when advertising out. Same way, when he advertises to branch 2, we'll make that he will change the next stop of subnet A to be data center again. Whereas when we advertise to data center, we'll just advertise them natively without changing anything, so that data center will receive both A plus B, both A and B subnets. Also, in addition to this, we will make the data center router 1 as primary, and we'll make this one as the secondary one, so that everyone, say example, when branch 1 sends traffic to C, he will prefer the primary router, and only when that goes down he will choose the secondary router. Let's see how we achieve that as well. Here in the vManage, let's get into the policy page. First, let's click on custom policy and then topology. I'm going to create a centralized control policy. So let's click on add topology. I'm going to use a custom policy. Now this policy is going to be from data center. So whenever you write a centralized policy, always think from the vSmart shoe, so that you will be able to understand that more clearly. So now from data center, when I receive from data center, what should I do? Sequence type, I'm going to add a TLOC route sequence. I'm going to match with TLOC. I actually haven't created a TLOC list yet, so let me create it here. DCRT1 10.1.1.101. We have color of MPLS. Let's save this and then call the one which we just created. So when I receive this TLOC, I'm gonna accept that, and then I'm gonna set a preference for that. Maybe we'll keep it as 500 for no reason, right? Same way, when I receive from router 2, let me create a TLOC list for that. DCRT2 10.1.1.102. MPLS IPsec public internet and IPsec. Right, now let's call DC router 2 action accept. The preference for router 2 TLOCs will be 400. Higher the preference, it will be preferred. Okay, and then for routes, let's add one more sequence. And what I'm going to do here is, I don't need to do any preference with the route, because we already have done preference there, right, with the TLOC. So let's click this one so that it gives an option of list, new VPN list. Let me VPN 10. Let me call both here. So VPN 1020. Let me have one like this, 10 and 20. And then from both VPN 10 and 20, I will receive all the routes. That's it, simple. I don't do any preference in the routes. I'll just prefer in the TLOC. That's what I'm going to do. In DC, we are not going to do anything else. When we receive that route from DC, that's all we are going to do. And then one more to the data center, to DC. I think, should we need 2 DC? No, I don't think we need 2 DC, because we just advertise everything towards the DC. We will just leave it to be the default. We'll not tweak that. We don't need to tweak that. Now let's add one for 2 branches. When we are advertising to the branches, let's first select TLOC. We'll match any, basically. Why do we need We'll match any and then send all T-logs to that. Because in our case, VPN 10 we need it to be hub and spoke, and VPN 20 should be full mesh. So anyway, we need to have direct tunnels between BR1 and BR2 to serve VPN 20. So we should tell branches about every other T-log. Say for example, if both VPN 10 and VPN 20 we want it to be hub and spoke, then we can only advertise about the data center T-logs to the branches. They don't need to form tunnels to the other branches also, right? So let's click route. This is where we have to tweak this. Now here we'll match the data center. So whether it is VPN 10 or VPN 20, the site ID, DC site ID is 100 if you remember. Let's save that and call DC. We'll advertise all the routes from this site. And then from the branches, what should I do? I should first match. Maybe let's match based on sites. Let's create a list for branches. Branches will be in 1001, starting from 1001, maybe in up to 1100. But in our case, I have only 1001 and 1002. If in case things comes up in future, this will be enough. So I just created one site list with all the branch site IDs and action. No, even before in match in VPN, not both VPN 10 and 20. We have to create one separately for VPN 10. That's VPN 10. Save, and when you advertise to the branches and a route from any other branch which falls under this list and it is a VPN 10 route, what you should do is you should send it, but so we should change the T-log as DC router 1 and router 2. We should set both. So let's create one commonly for both, which is DCRT1 2, which is going to be 10.1.1.101 and MPLS IPsec. Add one more. That's for the public internet. IPsec, if I go down, add save this and then set that. That's it. Save. And also we need one more rule where we match any route from branches, and if it is if it is VPN 20, I need to create one list. VPN 20, what I should do? Let me call this VPN 20 first. What I should do? I should not do anything. I'll just advertise them, because the plan for VPN 20 is it should be full mesh. So if I go through this step by step, when I am advertising to a branch about the data center, right? When I match only data center, that means it's matching both VPN 10 and VPN 20 routes from the data center. I'll just advertise them. Whereas when I'm advertising to a branch about other branch VPN 10 subnet, I will change the T-log to be data center routers. Whereas if I am advertising to another branch about VPN 20, I'll just advertise them, right? We'll not change any next stops. And in terms of T-log, we are advertising every other T-logs. Okay, that's it. Yeah. So from the vSmart's perspective, when I am receiving routes from data center, I'll tweak them so that I'll choose and prefer router 1 over router 2. And when I'm advertising routes towards the branches, I'll change the next stop for VPN 20 to be data center, and for VPN 20 we will not change anything. And also in terms of T-log, we will advertise all the T-logs to the branches. And for the data center, I think from data center we will receive all routes. That's what we did, right? We will receive all routes, and also we will receive their T-logs with a preference, right? DC router 1 will be preferred, DC router 2 will be less preferred. So I'm going to only tweak in these directions, whereas when the vSmart receives the routes from branches and advertises the routes to the data center, I'm not going to do anything. So let's keep going. Under centralized policy, we'll add a policy. Next, here we are going to call the topologies which we have created. It's a custom one. So first from DC, import that, and then we'll import 2 branches, import, next. Now we have to apply these policies. So as I told you, you should think from vSmart shoes. So 2 branches. So this should be applied in outbound direction from the vSmart when sending to the branches. So I'm going to choose branches, add. So 2 branches out towards the branches from DC, which is when I am receiving inbound. So think from vSmart shoes. When I am receiving the routes from data center, I should tweak this as per this policy. Let's preview this once. Okay, name centralized policy. Preview. Yeah, sequence 1 says that from DC router 1 T-log will receive with preference 500, DC router 2 will keep preference as 400, and in terms of route for VPN 10 and 20 I'll receive anything, and everything else will be rejected from the data center. And to the branches, I'll advertise all T-log, and in terms of route from data center, I'll advertise everything. Whereas from branches for VPN 10, I'll set the next stop, change the next stop. Whereas for VPN 20, I'll just advertise everything. That's it. And these are the lists which we have created, which is VPN 10, VPN 20 list, those things. And this is where the policy is applied. Site list branches in outbound direction, and this policy is getting pushed in the inbound direction. Okay, let's save this. I think we are expecting an error here. I will tell you why. Let's activate this. You see, there is an error. What does it say? It says that vSmart should be in vManage mode. We have actually onboarded the vSmart, but we haven't created a template for the vSmart, if you remember. If I go to devices, controllers, and for vSmart, if you see, it's in CLI mode. So vManage cannot push policies. So obviously centralized policies will be pushed to the vSmart, so that vSmart will change the routes accordingly and advertise to the branches and data centers, right? So he should be in vManage mode. For that, to make it simple, I'm going to create a CLI template, and I'm going to create it for vSmart, and I'm going to name it simple as vSmart. You see, there is an option, rather than going to the vSmart, copy pasting the config, we can just import the config. Let's just add Now we have a template, but this is a CLA template. Whatever we have created for the edge routers are all feature-based templates, feature-based device templates, and this is CLA-based device template. Let's attach device. Now it should show us the vSmart attach configure. If you see here, the template is attached successfully. Let's go back to the policy and centralized policy, activate. Now this policy will be pushed to the vSmart, and vSmart will change the routing accordingly and share the details with the branches, so that the branches will forward traffic according to the routing table. Now let's get into the edge routers. I have connection to the data center router. Let's first get into the data center router. Let me open for the second router as well. Router 2. Okay, from DC router 1 perspective, in VPN 10 we expect to see all the branch routes here. You see, we have VPN 10 route from BR1 this is, and this is BR2. We still have them, and the next stop is directly pointing to them from data center perspective. Let's quickly check in DC router 2. Show IP route VRF10. Let's first complete VRF10 and we'll come to VRF20. So we see routes to both subnets from BR1 and BR2, VPN 10 subnets. We see them, and his own local routes are also available, obviously. Let's get into BR2 now. From the branch perspective, what is he seeing? Let's check that. So let's ask him VRF10. Yep, he's getting a default route, which is obviously from the data center. It is not tweaked, nothing happens there. But let's go one by one. All these three subnets or data center subnets, they are received directly, but this subnet, you see the difference? If you remember, in our earlier section we validated this subnet and it was going directly, whereas now the next stop is data center router 1. It's not even data center router 2, because data center router 1 will be always preferred over data center router 2, right? So BR2 now will reach to the data center for reaching the VPN 10 subnet of BR1, right? Earlier he was going directly. Let me open BR1 router 1. Yep. I think I typed the host name wrongly, maybe. We'll see if we can change that. Let's quickly keep going here. VPN 10. What does he see? Yes, he is having default route from data center directly, and also the data center routes are available. Whereas when we check for BR2 subnets, you see the next stop is 10.1.1.101. That means he should go to the data center. Let me go to the BR1, maybe BR1 PC, and okay, if you see earlier, this is from the last section, it was going directly. Let's try now. You see there is an extra hop now, which is 210.1, the second hop. That's the data center. He's going via the data center. When I try to reach the data center, yes, I'm able to reach the data center, but obviously I'm going directly to the data center. Also, if you remember, I have some internet destinations in my lab. I think this is the IP. Yes, I'm able to reach them as well. They are in the data center. Okay, we have an internet link in the data center, and I have created a router in my GNS3. There I have some loopback IPs. If I remember, I have some 6 loopbacks, so I should be able to ping IPs in this range. Yeah, here it is. Okay, anyway, so this is going using the default route. We don't have a specific route for this, whereas these things we have a specific route. But the important point is VPN 10 is now hub and spoke. That's our requirement, right? Let's see now what's up with VPN 20. Let's first check the routing tables and then we'll come back to the host and validate. VPN 20, we expect to see no change at all. So from data center's perspective, he knows about the VPN 20 subnets in BR1 and BR2. Same goes for router 2 of the data center as well. Yes. Whereas when I go to the BR2, remember VRF 10 have changed to be hub and spoke. The next hop is changed, but we don't expect that to happen for this, right? Yes. Here you go. I have the BR1 subnet, VPN 20 subnet, but I can reach him directly. So as per our requirement, VPN 10 is hub and spoke. VPN 20 is still full mesh. Let me open up BR2 phone. And I think 10, 1, 10 to 10, 100, isn't it? What's the, no, I think it's 2000. That's the IP address of BR1 phone. Yes. So let's trace this. Trace 10 to 20, 10 to 20, 100. You see, we are going directly. We are not traversing via the data center. Whereas if I ping 10, 124, which is the data center, I obviously go directly. I'm able to ping, and let's check trace quickly. I go via the data center directly, right? So VPN 20 is still full mesh. VPN 10 is hub and spoke. Let us now configure branch 2 so that whenever the user traffic from branch 2 reach to any internet based destinations, they locally break out via the internet link in the site rather than going all the way up to the data center location for internet breakout. If you remember our design, there is an internet link available in the data center INET 2, and also there is an internet circuit which is INET 1 which acts as transport. So from branches perspective, they don't need to tunnel all internet traffic all the way up to the data center and then break out of the internet circuit available in data center. They can even break out of the internet link which is available in their own locations. But the only thing which concerns people in production is the security, right? When we break out to internet, we obviously need security in the edges. That will be taken care using a lot of options. We may have firewalls separate for every branch, or we can even implement security features available within the SDWAN, right? So for now, what we are going to do is we'll just quickly go ahead and validate the current internet path for BR2 host machine, and then we will enable local breakout, and then we'll follow the path again. Let me get into BR2 PC. From here, let me first ping 100, 100, 100, 100. This is just a loopback which I created to simulate internet. So I'm able to ping. Let me trace now 100, 100, 100, 100. Let that complete. Yes, you see the first hop. The first hop is 10.3, 1, 10.3, 10.1. That's my local gateway, and then it's going to 210.1.2. That's the data center, and the third hop is 10.1.1.2. That's the data center VPN 10 interface between DC router and core switch, I hope. and then followed by that he is reaching to the internet router. That's my IP which I have configured for the internet router. Okay, so he's taking the longer path, which is he's tunneling the traffic all the way to the data center and breaking out. Let me show you this as well quickly from BR2's perspective. If I do a show IP route BRF10, BR2 phone, oh my god, I mean BR2 phone. Let me do it from BR2 router, show IP route BR10. Yep, you see here I do have a default route from OMP, but the next stop is 10.1.1.101, which is the data center router, right? What we are going to do, we are going to make this breakout locally to this 100 destination. Let's see. For this, the first step is we have to go ahead to the internet interface, right? We have both internet and MPLS in BR2. We are going to break out via the internet interface. For that, we have to enable NAT on that internet interface. Yes, this is the interface, right? So if you see, this is the template which is getting attached to all the three sites, three routers to be exact, DC router 1, DC router 2, and then also to our BR2 router. If I enable NAT from this template, it's going to get applied to the data center as well. I don't have a device specific option, obviously. What I'm going to do here is I'll take a copy and then we will move BR2 router to a separate template. Let's copy this guy like with NAT. Copy. Here is the one. Edit, and we don't need to change anything. We'll just enable NAT in this template, and then we'll go to the template, device template for that location and change this one there. Let's go first here to NAT. Globally enable NAT, and when we are enabling NAT, we have a lot of options. We can do a overload to the interface IP, or we can enable a pool and then ask the router to NAT with that pool, or we can even create a loopback interface and then ask the router to overload or NAT to the loopback interface. Also, we can create static NATs, so that options are also available. These are helpful when you want to open connectivity from internet towards the local host, right? Say if you want to host an application in internet, then you might need to do static NAT. Okay, let's update. Yes, and as I told you, we'll change it in the device template now. This is it. Yes, and we'll edit. Go ahead and you see we have normal internet interface template. We'll change it to be the interface template which has NAT enabled. If you remember, I haven't changed anything apart from that NAT option, so that it's not going to prompt me to fill any values. It's already green if you see, right? This is mainly because I haven't played around with that keywords of the variables, right? So it will use the existing values. I can show you the config also. Here config diff, and if I go down, there should be some new commands which gets inserted. Yeah, you see there is some NAT related commands getting inserted, which is getting overloaded to Gigi2. In our design, Gigi2 is our internet interface. You see, and also NAT's NAT outside is there. Yes, those are the changes. Let's push this. So the first step, which is enabling NAT on the internet interface where we are going to break out, is done. So once this is pushed, it is done actually. Yes, it's pushed successfully. So the part 1 is done. The next part is adding a static route pointing towards VPN 0. So what we are going to do is we are going to get into the VPN 10 and then tell VPN 10 instead of using that OMP route, which is pointing to the data center, you just send whatever matching the default route to VPN 0, right? That means you're locally breaking out. So you have to get into the transport VPN, and then we already have NAT there, so that it gets NATed using that IP and goes out directly rather than getting tunneled. So to do that, we have to add a static route in VPN 10, right? If you remember, we haven't added any static route in our template, so that's what I'm going to do now. So this is the one, edit, under IP route, I'm going to add a new IP route. If you see, we do have this optional option, so that we can use the same template which we already have pushed to all sites, and then enable this route only for the branch. I'll show you. If in case we don't have that option, we should have created a separate template and pushed it only to the branch too. Now let me name it proper way. DIA, direct internet access 1. This is not VPN 0, this is VPN 10, right? And then I'm going to make it as optional row, and the next stop is not an actual next stop, it's VPN, right? We'll take it to the VPN 0, and then we'll enable that and add. I haven't given the prefix, we'll do the prefix. It's a device specific one, so it's going to ask me for changing in DC router 1, DC router 2 as well, but if you see already it's green. So since that is an optional row, whether we fill that or not, it can push the configuration to the edge, but we intend to change it for branch 2, right? So we'll go only to branch 2 and then get in there, search for our DAA route. Where is it? Yeah, here. Even though it's optional, we want that. So let me do 0000/0 update. Next, I'll just check for this, whereas the other ones are there, but we know that there is no changes in those routers. Let me close this. Okay, here you go, the config diff. This is the only change. There is a default route added in VRF10 pointing towards global. Global table is the VPN 0 of Cisco iOS XE SD-WAN router. Okay, let's push this. Once this is pushed, we should see that branch 2 is locally breaking out towards these internet destinations. Okay, I can see the config is pushed successfully to all routers. Let's get into BR2. Now let's check the same routing table, BRF10. If I scroll up, you see earlier it was pointing to 10.1.1.101. So if I do this now, that default route is changed to point to null 0, but don't worry, it's not actually null 0. If you see, there is a new route type which is *ND. If you search for that, that should be NAT, and then yeah, NAT DAA, NAT direct internet access, and the small one refers to that as well. Okay, now let's get back to our PC, which is in branch 2. Let's see if he's still able to ping the 100 IP. Yes, he is able to ping 100 IP. Now let's ask him. I'm not sure whether trace will work because we are getting NATed. Let's see. Yes, that's good news. If you see the second hop, which is 201.11.3.1, that's the next hop IP of internet interface in branch 2. This means that the traffic is sent in the underlay itself rather than getting tunneled, right? So the traffic goes from the BR2 directly into the internet cloud in the local site. And then further, if you see 1112, That's the internet connectivity link from the cloud to the router which I have in my lab, right? Internet server router, which I showed you earlier. So now we can confirm that DAA is successful. Branch router 2 is locally breaking out to all the traffic which is getting matched by this default route. There is lot more options. We can even locally break out for specific IPs, or also we can create data policies and then match traffic and take it into VPN 0. Rather than matching based on route, we can match based on applications also. Okay. Let us start discussing about application aware routing feature in Cisco SD-WAN. By default, Cisco SD-WAN will collect loss, latency, and jitter between every tunnel endpoints in both directions. Meaning, if you notice on the screen, there is two tunnels between site 1 and site 2 via MPLS and internet transports. If we look from site 1's perspective, it will continuously probe via both of its tunnel to site 2 and note down loss, latency, and jitter for each of the tunnels separately. Same way, site 2 will also capture data from its perspective in other direction. This process of capturing loss, latency, and jitter for every tunnel from every edge router in Cisco SD-WAN overlay will happen by default. This is totally irrespective of whether or not you have created an application aware routing policy. We can write application aware policies with a lot of granularity in Cisco SD-WAN and set actions based on these SLAs captured already by the Cisco SD-WAN. To configure an AAR, which is application aware routing, we will first create SLA class in vManage, then application list matching required applications. This can be either based on L7 or L3 or any other parameters as well. Followed by this, we will create an AAR policy where we will match the application and set actions based on the SLAs which we have defined. In addition, we can also enable logging for the same. If you remember from our lab topology in GNS3, I have added net term application which can simulate loss, latency, and jitter. We will create application aware policy so that all branch users who are destined to DC server will pass primarily through MPLS and failover via internet transport only when latency goes beyond the provided threshold in MPLS transport. Okay, let's start this. To demonstrate this application aware routing, I'm not going to match actual applications, rather I'm going to simply match it based on IP address, but I will show you this SLA driven failure, right? If you remember, I have showed you that in branch 2 and branch 1, we have added a device which is NetM. So we'll go into that NetM and induce latency in the link, and then we'll see whether it fails over to the other link or not. For this, from branch to PC, we will make a policy such that it primarily chooses MPLS1, and then when it sees a certain latency in MPLS1, it will fail over to internet. That's what we are going to do now. Before I do this, let me show you what's the current status. There is multiple ways to validate current status. We can get into the router and see there, we can check the flows, but there is an easy option, which is we can get into the vManage. There is option to simulate flows in vManage. I'll show you. Just hold on. Here in vManage, let's get into monitor, network, and branch to router 1. Go down to troubleshooting and then simulate flows. I'm going to ask the router if there is a traffic in VPN 10 sourced from this interface and it is destined to 10.1.10.100, what would you do? Right? We can even give application options as well. When you have an application level policy, that will help. For now, we don't have any application level policies, right? So if you see, what does the router say? He is going to load share the traffic between MPLS and public internet circuit, which I have. Simple. Let me go back now, start writing a policy, custom policy, traffic policy, and here in application aware routing section, Let's create new, and I'll just name it simple to be package app policy, right? And the first sequence rule I'm going to match based on destination data prefix. Okay, we can create a prefix list and then add it here. If you remember, we created for VPN list, site list, right? Same way we can do. What I'm going to do is I'm going to keep it simple by adding here. This is our destination, right? This is the server in data center. So when traffic is destined to that IP, what you should do is you should check the SLA class, right? That SLA class is, I'm going to create my own, my SLA, and if the latency goes beyond 50 ms, I don't want to use that. And if you see, right, there is lots and lots of options when you create an application aware routing policy. We will discuss that in our other video series. If you want to know in detail about app aware routing, you can follow me on that series as well. Now here we'll keep it simple. We'll just add a SLA, my SLA, and even though both of the links are within the SLA, I want you to prefer MPLS, right? When MPLS goes red, meaning he goes beyond the configured SLA, then you choose the other one, right? When SLA is not met in any of the link, what should you do, right? We'll not touch that for now. We'll keep it to be the default. Let's save this, and then default policy, we'll just save this, go back under the centralized policy, let's edit that, and under traffic rules here in application aware routing, we'll import whatever we have created. And even at the start, you could have directly came here into this centralized policy, and we can create the app aware routing policy here also. We can choose either way, right? Let's go back to application, and then under application aware routing, where I'm going to push this. I'm going to push this to, say, to all branches. Let it be in all branches, and then I'm going to select for specific VPN. I'm going to push it for VPN 10 only for now. Okay, let's push this. Now this policy gets pushed to the vSmart, but anyway, application aware routing policy needs to look into the data packet and then take decision based on that, right? So VH should have a copy of that. What vSmart does is, via OMP update, he will share this policy. I'll show you. You see it's success. If I go to this, and if I ask this router show SDWAN policy, what you received from vSmart, he will show you that application aware routing policy. You see, he shows you this. Now let's go back to the vmanage, and under network BR2 RT1 and troubleshooting, simulate flows. Let's do it again. VPN 10, source and destination same. Let's simulate now. You see, now he is saying that I'm going to use only MPLS, right? Here in BR2 PC, let's trace my path to data center IP, which is not sure where it is. Let's type it. You see, I'm taking 210.1. That's the MPLS IP, right? I'm using MPLS path. If I want to show you the current latency We can check that by show SDWAN route stats, and let's find out the MPLS tunnel from branch 2 to data center router 1. I think this is it. Remote system is 10.1.1.101, which is data center router 1, and local color is MPLS. The remote color is also MPLS. This is the one. And this is the latency. Mean latency is 17. That's why it's using MPLS. Next, let's just do a quick tweaking of the BFD pole interval. Let me show you this and explain what it is. Okay. If you see here, this template we have already created and pushed to the edges, and there is two options, which is multiplier and pole interval. This defines how long the edges takes to calculate the SLA, right? Say for example, by default it's 6 intervals, I mean 6 buckets, and 6 lakhs milliseconds, which is almost 10 minutes, I think. So by default it collects last 60 minutes data and then takes mean average, so that based on that mean average we'll act, right? When that mean average goes beyond the threshold, we'll act immediately and switch the traffic. If needed, we can tweak this as well. In our lab, I'm going to tweak this so that the convergence after the event, right? I mean, when I say event, when we increase the latency, it will be quick. I'm going to keep it 60,000, which is 1 minute, and 5 multipliers, which is 5 into 1, total 5 minutes. We should take care when we do this in our production, because it depends, right? When we keep it more aggressive, there is chances that things will keep, I mean, there is chances that the things will start flapping. Let me do this in the VH as well. Let's wait for this to be pushed. If we check the last one which we pushed to all the 3 routers, that was successful, and yes, this is successful as well. We have just changed the value. Let us give this network a minute so that it will converge properly. We'll get back into the router and check the current latency. Okay, now after around 2 to 3 minutes, I'm checking show SDWAN app route status. If you see, this is the tunnel from BR2 router all the way up to 10.1.1.101, which is the DC router 1, the tunnel via MPLS. The current loss is 0 and the latency is around 18 ms, right? Same way, if I do this again and go down, check for the internet tunnel. Yeah, internet path, that is also around 17 ms, and our path is still via MPLS because that is our preferred color. What I'm going to do now is I'm going to get into netm3, that is my latency inducer between the MPLS link. Yep, here let me click delay. Let us add a delay. Maybe let's increase it to 100 ms. If you remember, in our SLA threshold we configured it as 50 ms. If the link is beyond 50 ms, you should not use that. That's what our policy says. Let's wait for this to detect this, right? Yeah, you see it's still around 18. If we give it a minute, it will change from 18 to whatever it is currently, around 100. And also, if you see in every interval, there is 66 packets on an average, which is because I have given the poll interval as 60 seconds, 1 minute, right? And the BFD is per second. That means on an average, we'll see about 60 packets in a bucket, which is an interval again. Right, let's give this a minute. I'll pause this. Okay, here we go. If you see this tunnel statistics, the latency is about 216 ms now, right? This is the tunnel, MPLS tunnel to the data center router 1. If I do this again and keep going down, let me do that. You see, for the tunnel via public internet, that's still at 18 ms because we have increased the latency using NetM only on the MPLS link. If I keep going down, the tunnel to the secondary router via MPLS is also in higher value, and in the one via internet to the second router is still good, and the one to branch 1 via MPLS, whatever via MPLS is bad, right? Whatever via internet is still good. So that is what we expect. Let's go back to the vmanage. Now let's query this vmanage. Let's see what he says now. Branch to you see, now he says that he is using public internet. Yes, MPLS is up, but he have crossed the given threshold. But if you check for, say, for example, .1, some other IP other than the one which you have given in the policy, that is still being load shared. If you remember, we have created policy only for that server. So whatever decisions being taken will be taken only for the server. If I do for the server again, the server will be intelligently shifted to the other circuit. So this is what you can do for your critical applications over other normal applications. Let me also do this, get into ER2 PC, and you remember this trace that was through MPLS that time. Let's do it again. Yeah, the second hop is 201.11.10. That's obviously our internet in our lab topology. I think we have tested application aware routing, but in my lab, I have restricted it with IP subnet. The same logic applies even when you match based on applications. As we know, all our headend infra is running 26x code. We will go ahead and upgrade all of them to the next version, so that you will also get an idea about how to execute a Cisco SD-WAN headend upgrade. Let's start this process. The first step in upgrade will always start from vmanage. Let me show you the current versions. If you see here for WAN edges, they are all on 17.6.1a, and the edges, V edges in 26.1. Leave those for now. The target for us is controllers. The controllers vSmart and vBond are in 26.1. vmanage is also in 26.1, right? We'll start with uploading the image which we have into the vmanage repository, and then we'll follow that up by upgrading the vmanage, vSmart and vBond. I'm going to upload software image, add new software image to the vmanage itself. The file will be saved in the vmanage. Let's browse to the destination. First, let's upload the vmanage upgrade file. For vManage, it is a separate file, whereas for the other devices, vBond, vSmart, and vEdges, hardware vEdges, there is one single file. Totally, there is two files which we need to upload into the vManage now, so that we can upgrade our vManage, vBond, and vSmart. Okay, if you see here, the vManage upgrade file is successfully uploaded. Let me do the same for the other file. Yep. Okay, if you see here for software version 2063, I have a file which is Viptala 2063, which can be used to upgrade the vEdges and vSmart and vBond, and there is one for vManage himself. If I go back to maintenance software upgrade, now under vManage, it will give us an option to upgrade. There is 3 steps in upgrading a Viptala box. The first one is upgrade, which just installs the new image into the box and then activate. That is when the device will go for a reload, right? When you just upgrade, which means it just installs, it doesn't reload that time. Only when you activate, it reloads. So say for example, you can just push the image or install the image into a box during a working hour, and when you have your window, you can go ahead and just activate that image. And finally, when the router comes back up, router or the controller comes back up with the new image, you just go ahead and set that to be the default version, so that when the box powers off and comes back again, it will come up with the default version only. Let's start here. For the vManage, let me click upgrade, and where the file is, it's in vManage. You see, it's now showing 26.3. Let's click upgrade. As I told you, this is going to just install the image in vManage. It's not going to upgrade it. I'll pause this and get back once this is completed. Okay, if you see here, the process is completed. We have successfully installed the 26.3 version on vManage. We can quickly go back to maintenance software upgrade and to vManage. Here you see the current version is 26.1, but 26.3 is there available as well, and also the default version is 26.1. Let's do one thing. Let's go ahead and install the image in vSmart and vBond also. I'm going to push the image to both at the same time. Let's do this. You see, also there is option to activate and reboot after installing the image if we want to. But for now, we are not going to do that. We'll just install the image. I'm going to pause this again and we'll connect back once this is pushed. In the meantime, one more thing, if you see, even if I push both at the same time, the second one is saying it's waiting for the vBond to get completed. So it happens that it pushes one at a time. If you notice, the first one is pushed and installed successfully, then the second one started. Let's see how long this takes. Here you go. It is installed in vSmart as well. We'll go ahead and activate the image in vManage, and once vManage is successful, we'll go ahead and set default version there. Followed by that, we'll go ahead and activate in vBond and vSmart as well. Let's keep going. Let's get back to maintenance, software upgrade, vManage, and let's click activate. Which version you want to activate? 26.3. Let's activate it. Now this is at least going to take around 20-30 minutes, as I seen in my previous cases. So I'll pause and get back when this is ready. Okay, I can get in via the CLI into vManage. Let's just quickly see show software. You see here 26.3 is active, and then still 26.1 is the default that we have to come back and change. Let me also see request. Yeah, the services haven't started yet. Let's give it a couple more minutes. Okay. If you see here now, all the services came up in the vManage. It took some time, but eventually it came up. If we check the vManage GUI, that's up as well. Let me get into the vManage GUI. Yep, everything seems good, and let's get into the software upgrade page. And under vManage, if you see, the current version is 26.3 now, and 26.1 moved to the available version, but still default version is 26.1, which should not be the case. So I'm going to set the default version as 26.3 now. Okay, if you see, it's done. Now vManage is upgraded successfully. All three steps are done. If I get into vManage, you see the current version is 26.3, available version 26.1, default version 26.3. One of the thumb rule is you should make sure that the current version and default version is always same. Right, let's go ahead. Let's go into controllers. You see, we have the vSmart and vBond in 26.1, but the available version is 26.3 and default version is 26.1. We are going to activate 26.3 in these boxes. Let's activate 26.3. Now both the boxes will go for a reload and come back up. If you think you are doing this in production, obviously you will not reload both at the same time, because this is my lab. I'm doing this way. From here, let's go to maintenance, software upgrade, and under controllers, let's select both. You see the default version is 26.1. Select set default version and change it to be 26.3 for both. This is going to take not even a minute. Let's hold here. Okay, you can see that now the default version for both vBond and vSmart is 26.3. We can quickly go to maintenance, software upgrade, and check and validate the same under this tab. You see it's 26.3 now for both vSmart and vBond. And then the Vantage upgrade will also go through these three phases where we'll install, activate, and then set the default version. vManage being the critical component in Cisco SD-WAN overlay, there is multiple options to back up the Cisco vManage for recovery in case of a failure. Let us quickly discuss some of the options in which we can back up the vManage. The first option is that we can back up the configuration DB from vManage, so that when you restore this in a new vManage, you will be able to restore the configurations. But remember, this will not restore the statistics database. This is only the config database. So configuration DB and backup. Let's say I'm pushing it to home. I think I have to put, isn't it home? Okay, I think the command is path and then home. Path /home/admin/test backup. Let's see. Okay, if you see here, the backup is completed. It says that it successfully backed up the config DB under home admin. Let's quickly validate that. Under home admin, we are in home admin. If you see, let me do ls. You see, this is the backup file. You can SCP and then take this outside. Maybe we can use it for restoration if needed. The next option is to take a snapshot of the vManage VM itself. This is the most preferred way. This will restore the complete VM so that you will get the statistics DB as well. There is also other options in which we can give the vmanage the required redundancy by creating a cluster of vmanage, and also we can do DCDR based active standby vmanage. I think I do have covered all the major pieces of Cisco SD-WAN, and we have brought up a Cisco SD-WAN overlay together successfully. Even though this course is going to help you a lot with Cisco SD-WAN, I strongly encourage you to go through our other Cisco SD-WAN series in our channel, where we discuss the nitty-gritty of the Cisco SD-WAN in depth. I have shared the playlist link for that course in the description box. I always recommend people to explore the technologies in labs so that you can understand the concept in great detail. There is a lot of virtual lab options available for Cisco SD-WAN. Let's see if I can post a video showcasing the same to you. But please do reach to me via comment section or email for any queries or support. Take care and bye for now.